Okay, so this first question is asking us to write a fraction as a decimal. Now, the key thing to note is whenever I have a fraction, I've got the numerator, which is the number on top, and the denominator, which is the number on the bottom. And this line here actually means divide. So it means 7 divided by 100. Now, you might know your hundreds, tens, and units columns, in which case 7 over 100 is the same as 7 hundredths. So if you've got your decimal point, you've got your tenths column here and your hundredths column here, and you could just write 7 over 100 as 0.07 because there are 7 hundredths. But if you're not too great with your hundreds, tens and units, the other way, as this is a calculator paper, you can literally just type into your calculator. Either you recognize that 7 over 100 is 7 divided by 100, so you type 7 divided by 100 into your calculator, or you can use the fraction button. So the fraction button is over here and it allows you to just write your fraction in. So you write 7 over 100 and it will then just tell you 7 over 100. That's when you press format and then you go down and you choose a decimal and it automatically turns it into a decimal for you. So that would be 0.07 as a decimal. There's lots of ways to do this. You just want to pick the way that works best for you. In this question, I'm being asked to write down the value of 2 to the power 4. Now, when anything is to the power of something, this is called like the indice or the power, and it means that my base, the big number, is multiplied by itself however many times this number is. So it's 2 to the power 4, which means 2 multiplied by itself 4 times. So that would be 2 times 2 times 2. And they're being asked to work out the value of it, so I actually have to work this out. So 2 times 2 is 4, times by 2 again is 8, times by 2 again is 16. So therefore 2 to the power 4 would be 6. Okay, so to begin with, we've got metric conversions. So it's asking me to change 365 centimeters into meters. So it's helpful to just write down what the conversion is. I know that 1 meter is 100 centimeters. So that means that to get from meters to centimeters, I would multiply by 100. And to get from centimeters to meters, I would divide by 100. So I know that I need to change 365 centimeters into meters. So I'm going from centimeters to meters. So I'm going to need to divide by 100. So 365 divided by 100. Now, this is a non-calculator paper. So if you struggle dividing by tens and hundreds, then you could write it as a fraction. Or if we did dividing by 100, I know that 100 can be created by 10 times 10. So that is the same as dividing by 10 and then dividing by 10 again. So dividing by 10, if my number is a full number with no zeros in it, then I would, oh, what just happened there? Then I would just put 1 decimal point in. Okay, so I'm dividing by 10, I'm making it a tenth of the size. So 365 divided by 10 would be 36.5. But if I then divide it by 100, I'm moving everything. So that would become 3.65. The best way to think about it is that 300 divided by 100 would be 3. So therefore you know that 365 would be 3 point something. So that would be centimeters into meters. Then I need to change 2.7 kilograms into grams. And I know the conversion I should know is that 1 kilogram is 1,000 grams. So to go from kilograms to grams, I would multiply by 1,000. And to go from grams into kilograms, I would divide by 1,000. So I'm going from kilograms into grams. So I'm going to multiply by 1,000. So 2.7 times by 1,000. And just like before, the best way to do this is to think to yourself, okay, what would 2 times 1,000 be? I know that 2 times 1,000 would be 2,000. So I know that's the place value it's going to be, but it's 2.7, so it would be 2,700. When you multiply, again, you could do it by 10 by 10. So if you multiplied it by 10, that would become 27. If you then multiplied by 10 again, it would become 270, and multiplied it by 10 again. So you can do it step by step. Okay, so to start off with, we've got a rounding question. So I'm being asked to round 3,758 to the nearest 1,000. So the thousands column is this one here. This would be the hundreds, this would be the tens, and this would be the units. So I'm deciding essentially whether it is between 3,000 and 4,000. So I know that halfway between 3,000 and 4,000 is 3,500, and 3,758 would be roughly somewhere here. So it's going to round up to 4,000. Now the way that I do it, if I can't visualize the thousands, is I circle the digit that is in the thousands column, so that's 3, and I look next door to the number next to it. So the number next to it is 7, and when I'm rounding, I look next door, and if what is next door is 5 or more, I round my number up. So when I round up, I add 1 to the circled number, and everything else turns to zeros. So that would become 4, because 3 plus 1 is 4, and then I'm rounding it to 4,000. So the best way is to just think to yourself, okay, the thousands around 3,758 are 3,000 and 4,000. I know halfway is 3,500. Is it larger than that? If so, it's going to round up to 4,000. But if not, for the next question, we're being asked to write down a multiple of 6 that is between 40 and 50. Now a multiple is literally any number that is in the numbers times tables. So the multiples of 6 would be the 6 times tables. So what you can do is just write out the 6 times tables. It's a calculator paper, so you can even just use a calculator to do that. So you've got 6, 12, 18, and the way to find the 6 times tables is you just add 6 each time. So 6, 12, 18, 24, 30, 36, 42, 48, and then 54. And now it's asking you to write down a multiple that is between 40 and 50. So the ones that are between 40 and 50 would be either 42 or 48. So you just need to write one of those, and that's all you need. Next, I am rounding to one significant figure. So a significant figure is every non-zero digit before the number begins. So for instance, 0.000394, the first significant figure would be 3. But if you had 3.40009, the third significant figure would be 0. So 0 counts as a placeholder if it's in between 2 digits. But that's not relevant to this question, but just some extra knowledge there. So 56.78 to one significant figure means I circled the first digit, the first non-zero digit, which is 5. And I'm essentially saying, okay, that's 56. So what tens does that lie in between? So 50 and 60 would be what it lies in between. 55 is the halfway point, which is over here. And I know that 56.78 is going to be somewhere roughly over here. So 56 to one significant figure is closer to 60 than it is 50. But another way I can do that is I circle it, I look next door. If my number is 5 or more, so the next door neighbour, if it's 5 or more, I add 1 more to the circled digit. If it's 4 or less, I just ignore it and leave everything as it is. So just to show you what it would be if it was 54.78, I circle this, look next door, it's 4, so I ignore it and I round it down. So I turn everything to 0. So that would have been 50. But I add 1 more, so that becomes 60. And you can turn it into 60.00, but 60.00 is exactly the same as 60. So that's why I don't need to worry about that. Next, I'm ordering decimals. So this is a little bit trickier and it's really helpful to line them up so we can compare their place value. So I've got 0.078, I've got 0.78, I've got 0.87, and then 0.708. Now, just so that I can compare them, and with ordering decimals like this, it's kind of helpful to just fill in zeros for any of the place value where there isn't anything there. And then the cheat way is to then, once all of your decimal places are lined up, look at it and think of it in terms of that would be 870 and so forth. Or what we do is we look over here at the first decimal place. That is the 10th column, and that has the biggest place value. So I need to start with the smallest number. So I know that the smallest place value would be the one with a 0. So 0.078 is the smallest number. Then I look in this, look to see what the next smallest number is. So I've got 7 here and 7 here. They're both equal. So I'm going to look in the next column, which is the 100th column. And 0 is smaller than 8. So I know that this is going to be my next decimal. And then once again, I know that 7 is smaller than 8. So this must be the next one. And this must be the final one. Now, you might have noticed that you could have just said, okay, well, 870, that's 78, that's 780, and that's 708. And you could have ordered it that way, but either of those ways works. The quickest thing to do is to just add a 13. Over here, we've got expanding single brackets. So I've got 4e multiplied by e plus 2. So when I'm expanding brackets, I am multiplying the term on the outside by each term on the inside. So first I'm doing 4e times by e. And you can do some separate working on the side. What does 4e mean? It means 4 times e. So that means 4 times e times e. And any number or letter or anything that is multiplied by itself, it becomes that thing squared. Like if I write 5 times 5, I can write that as 5 squared. So e times e is going to become e squared. So 4 times e is going to become 4e squared. So that's the first part. And then I do the same thing. I multiply 4e by 2. So I can do my working out over here. I'm doing 4e times by 2. So 4 times e times 2. I multiply the numbers together. 8 times e, which becomes 8e. Okay, so expand. That word, we need to know what it means, and it just means multiply. So I'm told that here are 4 digits. Write down the smallest possible 2-digit number that can be made with 2 of the digits. So the smallest possible number, it's always like your highest place value that you want to be the smallest. So 1, I'm going to put first, and then the next smallest digit is 5, so that would be 15. Now write down the 3-digit number that closest to 200 that can be made with 3 of the digits. Okay, so closest to 200 is either going to, well, it would either have to be 100 and something or 200 and something. So again, I'm going to start with 1 over here. And then closest to 200 is going to be the highest possible value that you can have. So that would be 9. And then the next largest value is 6. So that would be 196. The 4/5 of a number is 32. So this is sometimes quite difficult because people just assume I need to work out 4/5 of the number. But if I think about it, so 32 has been split into 5 equal parts. And I know that 4/5, so 4 out of the 5 parts, are equal to 32. So then I need to find out what the number is. So if 32 is equal to 4 parts, I can do 32 divided by 4, which is 8. So each part is worth 8, and therefore the number must be 40 because I add all of the parts together. Okay, next I've got a sequence. So I'm told that here are the first 4 terms of the sequence, and I need to write down the next term. So whenever I've got sequences, I can just look to see what's happening. So how am I getting from one term to the next? So what do I do to get from 2 to 9? I'm adding 7. From 9 to 16, I'm also adding 7. From 16 to 23, I'm also adding 7. So generally sequences are always going to be going up by the same value. So in this case, the sequence is going up in the 7 times tables. So to write down the next term in the sequence, I would also add 7, and 23 add 7 is 30. So it asks me to explain how I got my answer. I added 7. And then I need to work out the 10th term of the sequence. So this is where I need to actually use what is called the nth term, which is the rule of the sequence. And you work out the rule by, first of all, deciding what times tables your number goes up in. So it's going up in 7 times tables. So we're going to write 7n. But if it was the 7 times tables, this is what it would look like. 7, 14, 21, 28. So I want to say it's the 7 times tables, but actually each time, instead of being the actual 7 times tables, it's 5 less, because 7 take 5 is 2, 14 take 5 is 9, 21 take 5 is 16. So therefore it's the 7 times tables, take away 5. So the nth term is 7n take 5. That is the rule of the sequence, and we can use the rule of the sequence to work out a given term. So in this case, it's telling us to work out the 10th term of the sequence. So n represents like the position in the sequence. So if it's the first, second, third, fourth. So in this case, n is 10, because I'm trying to find the 10th term. So 7n, what does that mean? It means 7 times by n. And then I'm going to take 5. So I know that n is 10. I'm going to substitute that into the rule. So I'm going to say 7 times 10 take 5. 7 times 10 is 70. And 70 take 5 is 65. If this is too confusing, another way that you could do it is just by keep on adding 7. It's a calculator paper, so that shouldn't be too hard. But generally, it's really good to know how to work out the nth term. Okay, so now I need to change 35 centimetres to millimetres, so it's helpful to write out my conversions. So I know that 1 centimetre is 10 millimetres, and this is just a fact that I need to memorise. And so if I'm trying to turn centimetres to millimetres, I know that each millimetre is 10 lots of 1 centimetre. So 1 centimetre, to turn it into millimetres, I times it by 10. So in this case, to go from centimetres to millimetres, I times by 10. So 35 times by 10 is going to give me 350 millimetres. Next, I need to change 7,700 millilitres to litres. So the fact I need to know is that 1 litre is 1,000 millilitres, and I'm changing millilitres to litres. So to get from millilitres to litres, what do I divide 1,000 by to get to 1? I divide by 1,000. So to turn millilitres to litres, I divide by 1,000, and 7,700 divided by 1,000 is going to give me 7.7 litres. The last one is I need to change 0.32 kilograms to grams. So once again, start with your fact that you know. 1 kilogram is 1,000 grams. And I'm trying to go from kilograms to grams. So to get from kilograms to grams, what do? I multiply by 1,000. So therefore I'm going to do 0.32 times by 1,000. And you can type that into your calculator because it's a calculator paper, which would give you 320. So the best way to do these is always write your fact that you know, or you should know, all your metric conversions. These are things that you're expected to know. And from there, decide whether you're multiplying or dividing. I'm then told a path is made of white tiles and grey tiles. A quarter of the tiles are white. There is a total of 56 tiles. Okay, so I know that there's a total of 56 tiles, and I know that a quarter of this are white tiles. So to work out a quarter, I can see that this 56 has been split into 4 parts. So I'm going to divide by 4 to work out what one part is. So 56 divided by 4 is 14. So I know that one part is worth 14. Therefore, to work out what 3 parts are, I would do 3 times by 14. 3 times by 14 is 42. And to double check that I've done it right, 42 grey tiles. 42 plus 14 must add up to 56. So double check. Am I right? 42 plus 14 equals 56. So I know I'm right. Okay, next. I'm told that there are 495 coins in a bottle. 1/3 of the coins are £1 coins. So the first thing I want to do is work out 1/3 of 495. And if I just try and visualize that, that means that 495 has been split into 3 equal parts, and I want 1/3 of that. So to work out 1/3, I would do 495 divided by 3, which is 165. So I know that there are 165 £1 coins. Next, I'm told that 124 of the coins are 50p coins. So there are 124 50p coins. And then the rest are 20p coins. So if I had 495 to begin with, and I know 165 of them are £1 and 124 are 50p coins, I can find out how much is left over by subtracting. So 495 take away 165, take away 124 is 206. So therefore, there are 206 20p coins. Now I need to work out the total value of the 495 coins. So let's have a go at doing that. So I know that there's 165 £1 coins. So 165 times by 1 gives me £165. Then I know that there's 124 50p coins. So if you want to turn it into money straight away, 50p is the same as £0.5. So I could do 124 times by 0.5. So 124 times by 0.5 gives me £62. And then for the last part, I've got 206 times by 20p. So 20p is £0.20. So I could do 206 times by 0.2, which is 206 times by 0.2 is £41.20. And total value means I add them all together. So in total, £41.20 plus 62 plus 165 gives me, so 165 plus 62 plus £41.20 is £268.20. I would say that's a good savings bottle. Okay, now we've got a pictogram question. Now a pictogram is just where you are trying to show a number using a picture. So in this incomplete pictogram, it shows the information about the number of cycles sold in a shop on Tuesday, Wednesday, and on Thursday. We are told that a total of 20 cycles were sold on Tuesday, Wednesday, and Thursday. So in total, all 3 of these pictures, so that's 1, 2, 3, 4 full wheels plus 2 half wheels makes 5 full wheels. So we know that 5 wheels must equal 20 bikes. So each wheel, if we divide 20 by 5, it tells us that 1 wheel must represent 4 bikes, because a pictogram, the picture represents a certain number of the thing you're doing. So in this case, we figured out that 1 wheel must represent 4 bikes because 5 full wheels make up 20 bikes. So then we've got a blank key. We can just write over here that 1 wheel is equal to 4 bikes. And now we're told that 8 cycles were sold on Friday. So I'm going to just need to do 1 full wheel, which makes 4, and 2 full wheels makes 8. And 15 cycles were sold on Saturday. So how do I make 15? You've got 4 plus 4, that's 8, plus 4 is 12. And so you want to make 15, which is 3 more than 12. So let's think about this one. So we're just going to do it in terms of circles. If a full circle gives you 4, you know that half a circle would give you 2, and half that again, So a quarter circle would give you 1. So to create 3, you're going to need to add on a quarter circle over here. So it's basically going to look like a 3/4 circle. So to make 15 cycles, we've got 1 cycle, so that's 4, 8, 12, and then my 3/4 of a circle. And we can just shade it in like that. So over here I've got a probability scale. So a probability scale is literally just saying from no chance to 100% chance to definite, what's the probability, what's the chance that something will happen. So semi-spin's a fair 4-sided spinner, and the fact that it's fair is important. It means that everything has an equal chance of landing. So on the probability scale, mark with a cross the probability that the spinner will land on B. So there's 1, 2 sides that would be B. So the probability of the spinner landing on B, remember probability you always write out of your total. So how many options do you have in total? You've got 1, 2, 3, 4 sides in total. So probability would be out of 4. And how many of those options are B? 1, 2. So the probability of it landing on B is 2 over 4. And what I can do is just simplify that into its simplest form. So 2 over 4, if I divided everything by 2, so 2 divided by 2 is 1, 4 divided by 2 is 2. So the probability would simplify to a half. So I could just mark that over here. Now it says on the probability scale, mark with a cross the probability that the spinner will land on F. Well, there are no Fs, so that would be 0 out of 4. So I'd mark my cross. Okay, now we've got the probability scale. So the probability scale is always from 0 to 100, and 0 is the probability of something, it's impossible, it never could happen. And 100, or 1 in this case, it means it's absolutely certain, there's no way it can't not happen. So people often say, what's the probability the sun will rise tomorrow is 1, because in all of human history, the sun has risen. Okay, so it shows the probability of each of the events, A, B, C, and D. Write down the letter of the event that is certain. So over here, this is where it would be certain, so that would be D. And over here, this is my scale, so that would be from 0, which is impossible, to D, which is to 1, which is certain. And write down the letter of the event that is unlikely. So halfway through my probability scale is where the chances of something happening are even, 50-50. So therefore, in between impossible and in between a 50-50 chance is unlikely. So that would be B. Anywhere kind of like in this region is unlikely. Further this way is very unlikely. Further this way is slightly. Okay, so now I need to read some coordinates. And whenever I read coordinates, I always go along the corridor and up the stairs. So I always read the X coordinate first and then the Y coordinate. So over here, I'm going to start at 0, 0, and I'm going to go along the corridor to where the coordinate is. So it's over here at 6. So my X coordinate is 6, and then it goes down to -2. So that would be 6, -2. I could draw that line there if I wanted to, but sometimes you just get to the point where you can look at the coordinate. You know, the X coordinate is here, the Y coordinate is there. So it's 6, -2. Next, I need to plot the point with the coordinates 2, 9. So again, I go along the corridor to 2. So the X coordinate is 2, the Y coordinate is 9. So along the corridor to 2, and then up the stairs to 9. So I'd plot it here at 2, 9, and label this point B. Next, it says, does B lie on the straight line with equation y equals 4x plus 1? So B was the coordinate 2, 9, so let's just replot it. And to check if a coordinate lies on a line, so like I said, every coordinate, it's the X coordinate first, then the Y coordinate. So for the coordinate 2, 9, X is equal to 2. So the X coordinate is 2 and the Y coordinate is 9. So in this straight line with the equation y equals 4x plus 1, 9 must equal 4 times by x, which is 2, plus 1. So we can substitute that in. So 9 equals 4 times 2 plus 1. Is that correct? If that is correct and that works, then yes, it does lie on the line. So does 9 equal 4 times 2, which is 8, plus 1? Yes, 9 equals 9. So yes, it does. And the working is obviously all of this. Another thing you could have done is just substituted one coordinate in. So we could have just substituted x in and said y equals 4 times 2 plus 1. So y equals 8 plus 1, y equals 9. And I know the y coordinate is 9, so I could have done it that way too. On the grid, draw the line with equation x equals 2. Okay, so generally the quick little shortcut method is that all of your vertical lines like this are going to be x equals, and all of your horizontal lines like this are going to be y equals. And the reason for that is because if I look at where x is minus 2, so this is where along the x-axis x is minus 2, but this coordinate here, that would be minus 2, 1. This coordinate here would be minus 2, 2. This coordinate here would be minus 2, 3. This coordinate here would be minus 2, 4. So each of the coordinates on this line, each of the x coordinates on this line would be negative 2. And that's why all of the vertical lines would be x equals, because they cross the x-axis at that point, which means that on that line, every x coordinate is going to be negative 2. Next, I've got a question about direct proportion. So 3 kilograms of meat, I'm told, costs £54. And Nina buys 2 kilograms of the meat, and I need to work out how much she must pay for that. So whenever I've got a question like this, it's helpful to just set it up as an equation. So I know that 3 kilograms is £54. I can then use the unitary method just to figure out what one lot of whatever it is costs. So in this case, 1 kilogram. How do I do that? Well, I think to myself, what do I need to divide by to get from 3 to 1? I'm dividing by 3. So I need to do the same to the other side. So I need to do 54 divided by 3. And this is a non-calculator paper, so I can use the bus stop method. So how many 3's go into 5? That's once. And how many 3's go remainder 2? And then how many 3's go into 24? That's 18. So 1 kilogram is £18. And if I know what 1 kilogram is, I can then use that to figure out what 2 kilograms must be. So what do I do to get from 1 to 2? I'm multiplying, because it's 2 kilograms is 2 lots of 1 kilogram. So I have to do the same to the other side. And I end up with £36. Next, I'm told that Joanne wants to buy a dishwasher. The dishwasher costs £372. Joanne will pay a deposit of £36. She will then pay the rest of the cost in 4 equal monthly payments. So a deposit is like the initial spend that you make. So sometimes you can't afford to buy something outright because you don't have enough cash. So you pay a deposit to secure that purchase. So the deposit is just the initial bit of money that you pay. So it costs £372 and she pays a deposit of £36. So she's paid that £36 off, so she doesn't need to pay it again in the future. So we can work out how much is left after the deposit. So we do 372 take away 36, which means she has £336 left that she needs to pay. She will then pay the rest of the cost in 4 equal monthly payments. So she needs to split 336 into 4 payments. So I'm going to divide by 4. And that is £84. So that is how the cost of her monthly payments. So remember, deposit is the initial spend. You place it down to hold your purchase, and then the rest is what you'd split into monthly payments. That's how a lot of people buy phones these days. You pay an initial deposit and then each month you pay a certain amount, or cars, any kind of high value item. I now need to write down a number that is a multiple of both 4 and 6. So I could start by writing out what the multiples of 4 are, which would just be the 4 times tables. So 4, 8, 12, 16, 20, 24, 28, 32, and do the same for 6. So I've got 6, 12, 18, 24, 30, 36. And which number is appears in both of these times tables, essentially. So when I get to 20, 24 appears in my 4 times tables and my 6 times tables. So that would be a number that is a multiple of both. 28 would only be a multiple of 4. So I wouldn't choose that because it needs to. Next, I've got a list of numbers. And from the numbers in the list, I need to write down a square number. So this is where it's really, really handy to just know your square numbers off by heart. And if you don't, we're really quickly going to recap them. So the reason square numbers are called square numbers is because they form a square. So you've got 1 times 1, and that forms 1. Then you've got 2 squares times by 2 squares gives you 4. Then you've got 3 by 3, which gives you 9. I'll write underneath actually because it just gets a bit messy. Then similarly, you've got 1, 2, 3, 4 by 1, 2, 3, 4. So 4 squared is 16, and so forth. You can do it with all of the square numbers if you haven't quite remembered that. So it's helpful to just write them out. 1, 4, 9, 16, 25, 36, 49, just so that you have them there, so that it makes choosing from the list a little bit easier. And then from the list, write down a square number. Well, out of these numbers, 25 is a square number because I know that 5 times 5 makes 25. So my square number is going to be 25. And write down all the prime numbers in a list. Now, prime number is a number that only has 2 factors. So it has 2 factors, 1 and itself. So essentially, the first few prime numbers are 2, 3, 5, 7, 11, 13. And if you can divide, apart from 2, 2 is the only even prime number. If you can divide it by 2, it's not going to be a prime number. So I can automatically cross out all of the even numbers. 2 is the only even prime number. So if it's divisible by 2, then it's not going to be even. Then I could try and think to myself, okay, are any of these divisible by 3? Well, 21 divided by 3 is 7. 27 is divisible by 3. Then I can try and think which of them are divisible by 5. So I'm literally crossing out all of the prime numbers. So 25 is divisible by 5. Any of these divisible by 7? Nope. 11? Nope. 13? Nope. So therefore, 23 and 29 would be the prime numbers that are in that list. So to eliminate anything that is not a prime number, first try dividing to see if it's divisible by 2, then 3, then 5, then 7, then 11, then 13. You've got a calculator, so that can help you. Okay, now here I've got a bearings question. So I'm told here is a map of an island and the diagram is drawn accurately. So a straight road joins the 2 villages, Backley and Cremford, and I need to work out the real distance between the 2 villages. So what I want to do, here I've got Backley, here I've got Cremford. I'm going to get my ruler and measure this line. Okay, so if you've got the paper printed out in front of you, put your ruler starting on 0 and then find out the exact point where it stops, and you should get around 5.5. You might be 1 or 2 millimeters off, but 5.5 is the measurement of that line on the piece of paper. So I know that it's 5.5 centimeters, and I'm told here they're always going to give you a scale. I'm told that 1 centimeter is equal to 0.5 kilometers. So for every centimeter, it's 0.5 kilometers. So I want to find out how many 5.5 centimeters would be. So what do I do on my map? For each centimeter, I'm going to times by 0.5, because how do you get from 1 to 0.5? You multiply by 0.5. So if I multiply by 0.5, I'm going to get my real distance. So 5.5 times by 0.5 equals 11 over 4. So remember, if you get a fraction, you can press the format button and decimal, which is not the most convenient of things. You used to have the SD button, but hey. Then it's 2.75 kilometers in real life. So we'd write that down. For the next question, it's saying find the bearing of Cremford from Beckley. All the bearing means is, in this question, it's not such a difficult one, but you're trying to work out what the angle is from due north to your other thing. So let's go through it bit by bit. So find the bearing of Cremford from Beckley. This is very important because when you start dealing with bearings, always start from the place it says from. So it's saying find the bearing of Cremford from Beckley. So I'm going to start from Beckley. And whenever you measure your bearings, you always start, you always put a straight line up and you measure it from due north, which just basically means up. So I'm going to start measuring it from here is what it means. And you measure it until you get to the line. So Beckley to Cremford, your line is over there. So essentially what it means is you want to measure this turn. So your due bearing up north would be 0, 0, 0. Bearings are written in 3 digits, but if you've got a 3-digit angle, you don't need to worry about that. So you get your protractor, you measure this angle here, and this angle is 130 degrees. So the bearing of Cremford from Beckley is 130 degrees. Bearings are a bit of a tricky one, so watch the video on bearings separately to try and understand it more fully. Next, I've got a prime number question. So NIDA writes down 2 different prime numbers, and remember the prime numbers are numbers that only have 2 factors, 1 and itself. So the first few prime numbers are 2, 3, 5, 7, 11, and these are things that you should kind of memorize and know off by heart. So she adds together her 2 numbers and her answer is a square number less than 30. So what I can do is think about the square numbers that are less than 30. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, because remember a square number is a number times by itself. That's literally the definition of a square number. So 4 times 4 then is 16, 5 times 5 is 25, 6 times 6 is 36. So the only square numbers under 30 are 1, 4, 9, 16 and 25. So let's think about the prime numbers that could be less, that could add to this. So we've got 2, 3, 5, 7, 11 are my first prime numbers. Then I've got 13. 15 is not a square number because it's divisible by 5. 17, 19, and then 23. If you're not sure about your prime numbers, you could list all of the numbers. Basically anything that is a multiple of 2 apart from 2 is not a prime number. That sign just means not equal to a prime number. Anything that is a multiple of 3, obviously 3 would be an extra factor, so it's not a prime number. And anything that's a multiple of 5 is not a prime number. So these would be the options that I have. So out of these, 2 plus 23 gives me 25, which is a square number. I could have also done 11 plus 5 because that gives me 16. I could have also done 7 plus 2 because that gives me 9. And are there any others? There might be some others, but basically any of these numbers added together to give you one of these numbers, which are the square numbers. So knowing your square numbers and knowing your prime numbers is quite important. So they're just numbers that you can either memorize, or for your square numbers, you just literally try multiplying each number by itself. So 1 times 1, 2 times 2, 3 times 3. Okay, so in this question, I'm told that Suha is going to buy 150 envelopes, and that here's some information about the cost of envelopes in 2 shops. So in Letters to Send, a pack of 25 envelopes you can buy for £3.49. And in Stationery World, you can buy a pack of 10 envelopes for £2.10. And if you buy 2 packs, you get 1 pack for free. So she wants to buy them as cheaply as possible. So I need to figure out which shop she should do that from. So 25 envelopes, I can do 150 divided by 25 to see how many packs of 25 she needs to buy. So 150 divided by 25 is 6. So she needs to buy 6 packs of 25, which cost £3.49. So if I just type that into my calculator, that tells me that she can buy them from Letters to Send for £20.94. So £20.94 from over here. Now, from Stationery World, she can buy a pack of 10 envelopes for £2.10, but if she buys 2 packs, she gets 1 pack free. So essentially, she can buy 30 envelopes for £4.20, because if she buys 30, she's essentially paying for 2 packs, and 2 packs would be 2 times £2.10, which is £4.20. So how many packs of 30 would she need to buy? Well, 150 divided by 30 is 5. So she would need to buy 5 of these, and 5 times by £4.20 is £21. So even though there's a nice deal where you get 2 packs and 1 pack free, it's cheaper to buy it from Letters to Send. So Suha should buy them from Letters to Send. And just make sure that you have all your... Now for the next question here, I've got a conversion graph. So I can use this to convert something. So in this question, it would be centimetres to inches. So I need to change 74 centimetres to inches. So I find where 74 would be. So this would be 70 because it's halfway between 60 and 80. And then I know that there is 1, 2, 3, 4, 5 little squares in between 70 and 80. So between 80 and 70, that's a difference of 10 centimetres. So I do 10 divided by 5, which is 2. So each little square represents 2 centimetres. So 74 would be over here. So I draw a line from 74 across to my graph, and then I go down. And that takes me over here. So halfway is 25, and from 25 to 30, that's 5 squares. So each square is going to be 1. So that would be 29 inches. Now the next question, it says Daniel's height is 6 feet and 3 inches. And I know that 1 foot is 12 inches. So what is his height in centimetres? So let's first of all convert his height into inches. So if 1 foot is 12 inches, then 6 feet, what do I multiply 1 by to get to 6? I multiply it by 6, so I'd have to do the same over here. And 12 times by 6 is 72. So 6 foot, 3 inches would be 72 plus 3, which is 75 inches. So I need to figure out what 75 inches would be. Now there's a few ways that I can do this. Obviously the graph doesn't go up to 75, so I'm going to have to pick a factor of 75. So I could pick 25, because I know 25 times by 3 gives me 75. So I go across my graph to 25 inches, I go up to the line and across, and then that takes me to 64 centimetres. So 25 inches is 64 centimetres. So therefore 75 inches, what do I multiply 25 by to get to 75? I times it by 3, so I'd have to times this by 3 as well. And 64 times by 3 gives me 192 centimetres. So that. Okay, so now I've got a question. I've got really itchy. The table shows a cricket club's income in 2016 from a fete, a quiz, and membership fees. And a fete is like a fair, if you didn't know. And I need to express as a ratio the income from the fete. So it's sometimes they put in words that not everyone is going to know, but yeah, it's like similar to a fair, or it's where you get together and you celebrate and there are stalls and things. So express as a ratio the income from the FATE to the income from the quiz to the income from the membership fees. So I know the FATE is 250 income. The entry fees were 13 people came at £5 each. So I'm going to have to do 13 times 5. 13 times 5, which is 65. So for the quiz, they made £65 from the entry fees plus £35 from the refreshments. So I'd do 65 plus 35, which is 100. So 100 in total from the quiz. And the membership fees, they had 25 members at £20 each. So whenever it says it's something each, that means per person. So you're going to multiply to work out the total. So 25 times by 20 is 500. So once again, it's ratio. So you need to express as a ratio the income from the FATE. So I write the FATE first, to the quiz, to the membership fees. So I'm going to write 250 to 100 to 500, and it says give your ratio in its simplest form. And just like when I'm simplifying fractions, I can just divide each little ratio by the same number and it will simplify it. So the easiest thing to do might be to divide by 10 to just simplify everything first. So if I divide by 10, I can basically just chop off that 0. So it's 25 to 10 to 50. And also when you're simplifying, you don't want to have decimals. That's why I couldn't divide by 100. So now let's think if there's any other number go into this. I could divide that by 5 as well. So 25 divided by 5 is 5, 10 divided by 5 is 2, and 5 divided by 5 is 10. And I can't simplify it any further, so the ratio in its simplest form would be 5 to 2 to 10. I'd always say when you're simplifying with ratio, start with a nice number like 10, 5, 2. If you tried simplifying it by 2, you could keep going. It doesn't matter how many times you simplify it, as long as you get there. Okay, next we've got solving equations. So when I'm solving an equation, all I'm doing is I'm trying to get the variable, in this case x or y, to be on its own so that I can find out what its value is. So over here I've got x plus x plus x equals 51. I can simplify that. X plus x plus x gives me 3x. So 3x equals 51. And I can use a function machine to help me. So what's happening to x is being put into the machine, it's being multiplied by 3, and 51 comes out. And then I can work backwards. So 51 divided by 3 gives me, well, that's a calculator question. It'll be a decimal. So 51 divided, oh, it won't be a decimal, it's 17. So x is 17 because I've divided both sides by 3. So if you can see, what the function machine is doing is it's showing you what's happening with the algebra. The first part shows you what's happening, x is being times by 3, and then to figure out what x is doing, you do the reverse operation. And that's exactly what you do with the balancing method as well. So for the next question, y is being divided by 4 and I come out with 3. So as a function machine, what would I do? I'd write y is being divided by 4 and the output is 3. So then I need to work backwards to find out what's happening. The inverse of dividing by 4 is timesing by 4, and 3 times 4 is 12. So I would end up with y equals 12. The next one is a little bit trickier. So what's happening to the f? It's being times by 2. I then add 7 and 18 comes out. So this reverse inverse function machine is going to tell me what I need to do. The inverse of adding 7 is taking away 7. So I know I subtract 7 from both sides and I'm left with 2f is 11. Once I've subtracted 7, I'm going to have to divide by 2, and 11 divided by 2 gives me 5.5. Okay, next I have to work out the value of t when v is 2. So this is a substitution question, and it's always really helpful to actually write down what the formula means. So t equals 4v, And for V, when a number and a letter are next to each other in algebra, it means they're being multiplied. So T equals 4 times by V plus 3. And you might just want to put it in brackets just to indicate that that's what you do first, because using BIDMAS, you always do multiplication first. Well, before addition anyway. So I know that V has a value of 2, so I could write that as 4 times 2 plus 3, and 4 times 2 is 8, and then 8 plus 3 is 11. Then I need to make V the subject of the formula. So when I make something the subject of the formula, it means I want to get it in the form of V equals. At the moment, T is the subject of the formula. So what I do is I can put my finger over the V, so put my finger over 4V, and then look at what else is left on that side of the equation. I've got a plus 3. So to move anything from one side of the equation to the other, we do the inverse operation, the opposite. So the opposite of adding 3 is taking 3. So the reason I do this is because it cancels on this side, so I'm left with 0. But because equations have to be balanced, whatever you do to one side, you have to do to the other. You can think of them as scales. Like if you take a weight off one part of the scale, you have to take the same amount off the other, otherwise the scales will tip. So therefore, T minus 3 must be equal to 4V. Now, what does 4V mean? Well, 4 times by V, because when a number and a letter are next to each other, it means they're being multiplied. So the inverse of multiplying by 4 is dividing by 4. So that would cancel that out on this side, and then I'd be left with T minus 3 over 4 equals V. So I've got V on one side by itself, so it is now the subject of the formula. So I say V equals T, take 3. Next, I have got a direct proportion question. So I'm told that 2.5 kilograms of apples cost £3.60. So what I might want to do is work out what 1 kilogram is. So how do I get from 2.5 to 1? Well, I divide by 2.5. So I'm going to have to do the same to this side. So I divide by 2.5. £3.60 divided by 2.5 is £1.44. So that means for 1 kilogram, you'd pay £1.44. I want to work out what 3.5 kilograms are. And how do I get from 1 to 3.5? I times by 3.5. So I'm going to do the same to this side to keep it in direct proportion. And £1.44 times by 3.5 gives me £5.04. So that's the cost of 3.5 kilograms. Now the next question here, I need to find the value of whatever I type this into my calculator. So we could do this bit by bit just to make sure that we don't get anything wrong. So let's work out the numerator first. So I type in the square root of 13.4, take 1.5, and that gives me 3.449637662. And then I want to work out what 6.8, so I put in brackets 6.8 plus 0.06 gives me 6.86. So I'm just doing it bit by bit just to make sure. And then I can work out what 6.86 squared is by just doing answer squared, which is, so let's write all of it out. So 3.496376662 divided by 47.0596. So I can just type that into my calculator. 3.449637662 divided by answer is 0.70733035981. Now you can do it all in one go if you feel confident. So you press the fraction button on your calculator, you press the square root of 13.4, take 1.5, and then underneath you'd open your brackets and write 6.8 plus 0.06, close the brackets and write that to the power of 2, and you would get the same answer. So if you're confident using a calculator, do it that way. If not, do it bit by bit and then. Next, we need to describe fully the single transformation that maps triangle B onto triangle C. So we can see it's like a reflection. If you put a mirror down the line, you can see it's a reflection. And we need to think, where is the line of reflection? Well, here, if I put the mirror there, each point is exactly the same distance. So I would say it's a reflection in the y-axis. This line here is the y-axis, this line here is the x. Okay, so this one is a rate of pay question. So rate of pay is essentially the same as your hourly wage, how much you get paid per hour. So Annie makes hats. She makes at least 17 hats per hour, and she is paid 46p for each hat that she makes. I don't know how you say his name, but Riaz is a waiter. He works 35 hours and is paid a total of £266. Show, so whenever you have a show that question, it means you show every tiny little step of your working. Show that Ellie's hourly rate of pay is more than Riaz's hourly rate of pay. So let's start with Riaz. So his is simple because his hourly rate of pay is, to work out the hourly rate of pay, you do the total pay divided by number of hours worked. So that's how, when you first start having a job, you can work out what your total pay is, divided by how many numbers of hours you work, and that will tell you how much you get paid per hour. So Riaz, his rate of pay is going to be 266, which is his total, divided by 35. And if we do that, we've got 266 divided by 35 gives me 7.6. So 7.6, if I turn it back into money, is going to be £7.60. Then I need to figure out what Ellie's hourly rate of pay is. So she makes at least, so this is a little bit of a not a great worded question, because, you know, if she makes 20, she'll get paid more, but let's just go with the basic. If she makes at least 17 hats per hour, that means that in 1 hour, she's going to get paid for those 17 hats, and she gets paid 46 pence for each of them. So 17 times 46 is going to tell me how much she gets paid. How much money she makes in an hour. So that's 786 pence, because I'm still working in pence. To turn it back into pounds is £7.86. So therefore, Ellie's rate of pay is more, because £7.86 is greater than £7.60. So for this question, it's very important you showed both of their rates of pay and compared them. Next, I've got a rotation question. So I need to rotate shape A 90 degrees clockwise about the center O. So O, the center, is 0, 0. It's also sometimes referred to as the origin. And what you do is you place your tracing paper over the shape clockwise. If you think about a clock, so a clock starts with like 12, then it goes to 3, and then 6, and then 9. Clockwise is going in the direction of the clock. So what we would do is put our tracing paper above it and just shift it. So you'd mark a little point on all of your vertices, and then you shift it to the right. And then once you've done that, you just draw down the vertices, write them down, and then you join the shape up. So this is done using tracing paper, and your shape should look like this. Now I have to do a table of values. So I need to complete the table of values for y equals a half x minus 1. The best way to do these is to start from this side, because they're the positive numbers. They just make your life easier. So y equals a half x. Well, a half is the same as 0.5. You times that by x, and then you take 1. So over here, x is 3. So I'm going to do y equals 0.5 times by 3, and then I'm going to take 1. So that would give me 1.5 take away 1, and 1.5 take away 1 is 0.5. So over here, I've got the value of 0.5. They've already done the value of 2, so when x is 2, then I'm going to do the value for 1. So y is 0.5, half of x, so half of 1, and then I take away 1. So half of 1 is 0.5, and 0.5 take away 1 is minus 0.5. You've got your calculator that you can use as well. Then I'm going to try it for 0. Now, once you've done a few, you might notice a pattern, but let's just try keep going on anyway. So y is 0.5 times by 0, and then I take 1. So 0 times by anything is 0, and 0 take 1 is minus 1. And the last one, you've got -1. You might have noticed a pattern, and that's the good thing about doing these, is that they're always going to show you a little pattern. So you can see that it's going down in 0.5s. So I can predict that it's going to be 1.5. But let's show if that's true. So I've got y is 0.5 times by -1, take away 1. So 0.5 times by -1 is minus 0.5. And minus 0.5 minus 1 is minus 1.5. So to complete a table of values, think about what the algebra is doing. So you could have left it as a half times by x, take away 1 if you wanted to, whichever works best for you. And then you use these numbers, these are your x values, you substitute them into the equation over here, and then you can figure out what your y value is. So over here, I'm being asked to draw this, and let's just fill it in. So it was, what was it? 0.50 minus 0.5 minus 1 minus 1.5. And I want to plot that from -2 to 3. So I always go along the corridor and up the stairs. So along the corridor to -2 and then down to -2. So I put an X over here. Always mark your coordinates with an X. Then you've got -1, and then you go down to -1.5. Then you've got 0, you go down to -1. Then you've got 1, you go down to 0.5. Then you've got 2 and 0, and 3 and 0.5. Now, this is a straight line graph. I don't know why it says quadratic graphs. I think I was very tired when making this. So it's a straight line graph, and you have to, I don't know why that point just disappeared. You have to join your points together with a straight line and a ruler, and then you've got your straight line graph. Now, use a graph to find the value of x when y is 0.3. So when y is 0.3, this is the y-axis. So we're going to go up, and that's 0.1, 0.2, 0.3. We're going to go along that line until we reach the x coordinate, and then we read downwards. Now mine might be a little bit different because I'm not using the pencil and stuff, but that would be 2.5 is halfway, so 2.6, 2.7. So x is 2.7. Okay, Andy went on holiday to Canada. His flights cost a total of £1,500. He stayed for 14 nights, and his hotel room cost $196 per night. He used Wi-Fi for 12 days, and Wi-Fi costs $5 per day. The exchange rate was $1.90 to £1. Work out the total cost of the flights, hotel room, and Wi-Fi, and give your answer in pounds. Okay, so I know that his flights were £1,500, so that's nice and easy. I don't need to do anything there. Then what I want to do is work out the total cost of his hotel. So his hotel room is 14 times by 196, because each night cost $196, and he stayed there for 14 nights. So that would be $2,744. And then his Wi-Fi cost $5 a day, and he used it for 12 days. So I do 12 times 5, which is $60. So in total, he spent $2,744 plus $60. So 60 plus 2,744, which is $2,804. So I know he spent £1,500 plus this. Now I know the exchange rate is $1.90 to £1. So if I want to figure out what $2,804 is, I need to figure out what the how I can convert dollars to pounds. So there's a few ways you can do this. Either you can do a complicated way, or you can do the simple way. So you know, to get from dollars to pounds, how do you get from $1.9 to 1? So 1.9 divided by 1.9 gives you 1. So you know you divide by 1.9 to get to £1. So I'm going to do 2,804 divided by 1.9. So 2,804 divided by 1.9 is £1,475.78. Let's round it to 79. So the complicated way is you could have said to yourself, okay, what is 2,804 divided by 1.9? That is 1475. So you know that you need to times this by 1475.78 to get to dollars. So therefore you would have times this as well. You end up with the same answer. It just depends which method you prefer. And for your final answer, you just need to add 1,500 plus this. So 1,500 plus 1475.79 gives me £2,975.79. And I've just rounded it up because with money generally you round up. So £2,975.79. With money, you don't have 0.798 pence. You always have two, like there's 100 pence in a pound, so you're always going to round that. Okay, now it says if there were fewer dollars to a pound, what effect would this have on the total cost? Okay, so let's say the exchange rate was $1.50 to £1. Well, what effect would that have? It would mean I divide the amount by £1.50. So his amount was 2,804. So I divided it by 1.9 to get 1,475. But if instead I were to divide it, for example, 1.5, let's just see what impact it would have. So 2,804 divided by 1.5 leaves me with £1,869. So the less money, and let's just show another example. So let's make it even smaller. Let's say 1.2. 2,804 divided by 1.2 is £2,336. So essentially, the fewer dollars to the pound, the more expensive the holiday would have been. Because essentially, if £1 is $1.90, you give a pound and you can get anything that's worth $1.90. But if £1 is worth $1.20, you get less for your money. So the higher the exchange rate, the better value for money it is for you. So yeah, if there were fewer dollars to a pound, then the total cost of his holiday would have. I need to factorize. So factorize means pull out the largest factor and take it outside the bracket. So I know I'm going to put this into brackets. And I want to think to myself, what's the largest number that multiplies into 5 and minus 10? So 5 would be the largest number that multiplies into both of them. And then 5 times by what gives me 5, or 5 times by 1. And 5 times by what gives me 10, or negative 10, that would be minus 2m. And now the next part says factorize fully. So once again, I'm looking at the largest factor. So a way that we could do this is to try and write it all algebraically. So I know that 2a squared means 2 times a times a times b. And then 6ab squared. I'm trying to write it so that in terms of its factors. So the factors of 6 are 2 times 3 times by a times b times b. So then I can think, okay, what's common Well, 2 is the largest number that's common, so that will go outside the bracket. Then I've got 1a in common, so that will go there. And then I've got 1b in common as well. So 2ab would be the largest factor that I can squeeze out and put outside the brackets. And then everything else I just leave. So here, 2ab multiplied by a would give me 2a squared b. And then what's remaining over here, I've got 3b. So that's how I do. Okay, next we've got a frequency tree. So I'm told that each worker in a factory is either left-handed or right-handed. And with a frequency tree, the key thing that you need to know is that this is going to add up to both of these, okay? So first I start off by filling in what information I've got. I'm told that 22 of the 45 workers are male. So I know that 22 of the workers are male. I know that these two little sections are going to have to add up to make 45. So what I could do is I do 45 take away 22, and that leaves me with 23. So I now know that there are 23 females. Again, the same thing happens. These two branches are going to have to add up to make 22. And these two branches here are going to have to add up to make 23. So I can fill in the information I've been given. It says 16 of the 34 right-handed workers are female. So I know that right-handed workers must add to make 34. And I know that 16 of them are female. So if I did 34 take away 16, that leaves me with 18. And now I've got the information that I need because I know that these two branches must add up to 22. So 22 take away 18 is 4. And 23 take away 16 leaves me with 7. So hopefully you can see that each time, I don't know what the actual word is for it, but this sums to 45. Like if you think of it as a column, this will sum to 45 and this part here will sum to 45. So it's just a way of separating your information into smaller and smaller cells. Okay, next we've got a bit of angle reasoning. So Mary needs to work out the size of angle X in this diagram, and she says that X is 63 degrees because base angles of an isosceles triangle are equal. Mary is wrong. Explain why. Essentially, her reasoning is right, except she's applied it to the wrong thing. So normally, you're shown an isosceles triangle like this, and you're told the base angles are over here. But the base angles are essentially wherever your two equal sides are, the angle that's trapped in between that, so in this case X, that's not a base angle. The other angles are. So this would be the base angle. So Mary is wrong because X is not a base angle. Angle BAC would be the base angle. So if we turned that around, this is what it would look like. So C would be at the top, A over here, B, and that would be 63. And this would be your base angle here, and that would be X. It's basically the triangle that's just been turned over. Okay, next I'm told that William needs to work out the size of angle Y in this diagram. I know that I've been given parallel lines. So what I can do first of all is just extend this just to make my life a little bit simpler. It might help, it might not, but it helps show the transversal, which is the diagonal over here. Just might make things a little bit easier. So William writes angle EGH. So angle EGH would be this angle here. It's 57 degrees because corresponding angles are equal. Well, that's wrong because this angle and this angle here are alternate angles. So when they're on alternate sides of the diagonal, that's when we call them alternate angles. So we'd say angle EGH is 57 degrees because alternate angles are equal. the corresponding angle that he's talking about, if I wanted to have a corresponding angle, it would be over here. So it's important to know your different angle rules. His other reason is y is 180 take away because angles on a straight line add up to 180 degrees. So that one's also not amazing. It should have been co-interior angles, sum to 180 degrees, but that one might be forgiven because perhaps he worked out that this is 57 degrees. But yeah, the main one is this is definitely not a corresponding angle. Okay, next I need to work out percentage of an amount. So there's the quick multiply out method, which would be really helpful for a calculator paper or if you're good at multiplying by decimals. If not, then we can do it the breakdown method. So what does 15% mean? It means 15 out of 100, but how can I break up 15% in nice, easy percentages? I know that 15% is the same as 10% plus 5. And something that you should all know is how to work out 10%. So 10% is one of the quick percentages that you should know the cheat method for. So to work out 10% of anything, you just divide the amount by 10. So I know that 15% is 160 grams. Oh no, sorry. I know that 100% is 160 grams, and because that's my amount, that's the thing that I'm trying to work out. So 10% is going to be divided by 10. So 160 divided by 10, to divide anything by 10, if your number ends in zeros, we just chop off the 0. So 10% is 16. And then if I know what 10% is, I could work out 5%, because what do I do? How do I get from 10 to 5? I divide by 2. So I need to do the same over here. 16 divided by 2 is 8. So I know that 15% is 10% plus 5%. And I've worked out that 10% is equal to 16 and 5% is equal to 8. And 16 plus 8 is 24. Therefore, 15% of 160 grams is 24. Okay, so here I've got a Venn diagram. Now this funny little symbol that I can never seem to recreate, it means the universal set. Okay, so all that means is every possible number that could appear inside my Venn diagram. So we can think of like the Venn diagram as your little universe. The only things that exist in this particular universe are the numbers that are in the universal set. So all of the numbers in the universal set are odd numbers less than 30. So I can start by just writing them down so that I know what my possible numbers would be. So every odd number that is less than 30, so that would be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, and 29. Now in set A are the numbers 3, 9, 15, 21, and 27. So that's set A. And in set B are the numbers 5, 15, so 15 appears in both sets, and 25. I need to complete the Venn diagram to represent this information. So essentially, every number I've circled in pink is in the section A. Every number that I've circled in green will appear in section B. And anything that is circled by both has to appear here, because this is like it's called the intersection. It's where A and B intersect. So everything that qualifies for being in A and B. So in here, I am going to write 15. And then I can cross it out because I've already written it in my Venn diagram. Then let's start with what I would write for A. So I've got, oh, what's happened there? So I've got 3, 9, 21 and 27. And then what do I have for B? I've got, well, that uncircled itself for some reason. I've got 5 and 25. And then what I have to do is any numbers that are left over, I write on the outside. So here I would write 1, 7, 11, 13, 17, 19, 23, and 29. Okay, so anything that doesn't fit inside of your little circles, you write on the outside. Now next it says a number is chosen at random from the universal set. So the universal set is like these numbers here. So I want to figure out how many numbers there are in total. So let's just count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 numbers in total, and probability is always the denominator is going to be your total. So what is the probability that the number is in the set A? And okay, so a little bit of terminology. So you've got this sign and you've got this sign. And I like to think of it as, this is like the shape of a rainbow, right? So you can just imagine it as a rainbow. And this means, what's the probability of this and that happening? So I call it the rainbow. And over here, this kind of looks like a valley because valleys like go down. So this is the probability of this or that happening. So when I have to do the probability of this part, I just work out what is in the intersection. And when I have to work out what's in the valley, it's what's in the set A or set B or in both. So essentially what's in everything inside of the circles. So what is the probability that the number is in set A union B? That's the terminology, the technical terminology. So that just essentially means everything in here and here. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7. 7 out of a total of 15. Next, I've got simultaneous equations. So the key thing with simultaneous equations is step 1, ensure that one of your variables are equal. So over here, if I rewrite this, 3x plus y equals -4, and 3x minus 4y equals 6. So nicely, this is a nice one. Over here, my x's, so my variable of x has the same value. So that's nice because sometimes you have to actually multiply your equations in order to get that. So once you have variables that are the same, so they have the same coefficient, so like y and 4y, they're not the same because y is not the same as 4y, whereas 3x is equal to 3x. So I circle those and I think, how can I eliminate them? So do I eliminate, do I add, or do I subtract in order to eliminate? Well, 3 take away 3 is 0, so I know I'm subtracting. And then what I have to do is I have to subtract the whole equation. So 3x take away 3x is 0. Y take away, so remember that y is a single y, so 1y, take away minus 4y. So I could imagine that's the same as saying 1 take away minus 4. When you've got two negatives next to each other in between the numbers, you're subtracting, you're taking away a negative. So it's the same as adding. Like if you think about it, it's, you've got this like large bucket of ice to cool your drinks down, but you take away the negative ice cubes, okay? So the more ice cubes you take away, the warmer it's gonna get. So when you take away a negative, it's the same as adding. So that would become 1 plus 4. So 1 plus 4y would be 5y. And then minus 4 minus 6. So it always helps to actually just have a little number scale, just draw one really quickly. Whenever we add, we go up the number scale. And whenever we subtract, we go down the number scale. So I start at minus 4 and I'm subtracting 6. So I'm going to go down the number scale. So that would be minus 10. So I know that 5y equals minus 10. Now I can use all of my knowledge of solving equations to figure out what y must be. So 5y means 5 times y. So I'm going to have to divide both sides by 5. and figure out that y equals minus 10 divided by 5 is minus 2. So I know that y equals minus 2. I figured out the first part. Once I've figured out what one variable is, I substitute into whichever equation I want. So either this equation or this equation. And the easiest one is where y is going to have the lowest value. So I know that 3x plus y equals minus 4. I know that the value of y is minus 2. So I'm going to say 3x minus 2 equals minus 4. And then I can solve the equation. So I add 2 to both sides. So minus 4 is minus 4 degrees, and it gets 2 degrees warmer is minus 2. Remember, when we add, we always go up the number scale. So 3x is negative 2. And what would I have to do to figure out what x is? I'd have to divide both sides by 3. So x is going to be minus 2 over 3. And to double check if that works, we can just double check by the next equation. So 3 times by minus 2/3 minus, and y is minus 2. So minus 4 times minus 2 should give me 6. Let's double check. We've got our calculator. So 3 times by 2/3 equals minus 2. And then 4 times by minus 2 is minus 8. Remember, when two negatives are next to each other, it's the same as adding. So minus 2 plus 8 equals 6. So using the double check, I know. Okay, now here in this question, I am substituting into a formula, and it's a bit of a tricky one because I've got negatives. So the best thing to do when you're substituting into a formula is just ask yourself, what does the formula actually mean? What does the algebra mean? So 4x, when a letter and a number are next to each other, it means they're being multiplied. So 4x means 4 times by x, and then 3y means 3 times by y. I can just put that in brackets because that just means that I do 4 times x first, then I add 3 times y to it. So to work out p, I'm going to, wherever I see an x, I'm going to substitute the value that I've been given, which is 4. So I'm going to say 4 times by something and 3 times something. I'm told that x is 5, so I'm going to say 4 times 5. And I'm told that y is negative 2. So I'm going to substitute negative 2 where there's a y. So let's work through it. We always do what's in the brackets first. So 4 times 5 is 20. And 3 times negative 2 is negative 6. Now this is where you need to be very careful. When you're adding a negative, it's the same as subtracting. So that would become 20 take away 6. Next, I'm told that ABC is an isosceles right-angled triangle, and I'm given the area of the triangle, and I'm told to work out the value of x. So again, there's quite a few ways that we can do this. The fact that it's an isosceles means that these two sides are the same. It's a right-angled triangle, and I know what its area is. If you like visualizing with a square, no, let's not do that way. Well, it honestly depends on what your former knowledge is, but let's just go with the area of a triangle. So you always try and think to yourself, what knowledge do I know? Well, I know that the area of a triangle is base times by the perpendicular height divided by 2. So often, as long as there's a right angle, they're the two heights that you're going to use. So the base is 3x, the height is 3x, and then I'm going to have to divide that by 2. So I can just think to myself, okay, I'm going to use the formula for the area of a triangle. This is the formula. I've been told that the area of the triangle is 162, so therefore I know 162 equals 3x times 3x divided by 2. So now it's up to me to simplify that. So 3x times by 3x, that's the same as saying 3 times x times 3 times x. 3 times 3 is 9, and x times x is x squared. And then that's being divided by 2. So I want to rearrange this because I want to find the value of x. So to rearrange an equation, I essentially move everything from one side of the equation to the other by doing the inverse function. So you can use a function machine to help you decide what you need to do first. So when we use a function machine, we start with x and we think, what's the first thing that's happening to x? Well, it's being squared. Then it's being multiplied by 9. And then finally, it's being divided by 2. And I know that the end result of that is 162. So to work out what x is, I'm going to go backwards using the function machine and do the inverse operation. The inverse of dividing by 2 is timesing by 2. The inverse of timesing by 9 is dividing by 9. And the inverse of squaring is square rooting. And that's going to tell me what x is. You can use the function machine to determine what you do first, or you can just use the inverse laws of BIDMAS. So the first thing I'm going to do to solve x is times by 2, just like it tells me here. So 162 times by 2 is 324. So 324 is 9x squared. The next thing I know I need to do is divide by 9. So I divide both sides by 9, and that cancels out here. And 324 divided by 9 is 36. So I know that 36 is x squared. And if you don't know your square numbers that well, you just write in the square root of 36 on the calculator, and that will tell you what x is. But otherwise, you might know that the square root of 36 is 6. So you've worked out that the value of x must be 6. So it is quite a tricky question. There are quite a lot of things that you need to know, but primarily it's applying the area of a triangle, simplifying your algebraic expression, and then solving. Okay, so here we've got a percentage profit question. So I'm told that Emily buys a pack of 12 bottles of water, and the pack costs £5.64. She sells all 12 bottles for 50p each, and I need to work out her percentage profit. So to work out the percentage profit, I have to use this formula. So to work out the percentage profit, you're working out the difference between your new value, take away your original, you divide that by your original amount, and you times it by 100. So my new value, she has sold all 12 bottles for 50p each. So 12 times 50 is 600p, which is £6. So her percentage profit is going to be the new value, which is £6, take away the original, which is £5.64, divided by the original value, and then I times it by 100. So you've got a calculator, so we can use the fraction button once again over there, and we type in 6 take away £5.64 over £5.64, which gives me 3/47, and then I just times that by 100, which gives me 300/47, and then you can press the format and the decimal number to give you 6.382978. Going on, it says give your answer correct to one decimal place. So I'm going to look at the first decimal place, look next door. If the number's 5 or more, it means I'm going to round it up. So that would be 6.4 to 1 now to fit them in. Okay, next we've got a factorise question, and factorise means take out the highest common factor and put the rest in brackets. So I've got 4m plus 12. Now I want to find the highest common factor of these two terms, the largest number or piece of algebra that goes into them. 4m means 4 times m, and 12, if I know that 4 is the number here, can 4 multiplied by something make 12? Yep, 4 times 3 makes 12. So I know that 4 is the largest factor. I put that outside the brackets, and then I think to myself, 4 times by what gives me 4m, 4 times m, as it says here, and then 4 times what gives me 12, 4 times 3. So that's what I do to factorise. I squeeze as much as I can out of the expression, and I put that on the outside of the bracket. Now, to double check if you've done it right, you could just expand it back out. So that would become 4m plus 12. Okay, next I've got a mixed question. So on Saturday, some adults and some children were in a theatre. The ratio of the number of adults to the number of children was 5:2. Each person had a seat in the circle or had a seat in the stalls. Okay, so adults to children.
Okay, I found this on the web for Hey Adults.
Okay.
Check it out.
Right, so adults to children is 5:2. It says 3/4 of the children had seats in the stalls. Okay, so you either have circle or stalls, and I know that 117 children had seats in the circle. So 117 had seats in the circle, and I know that 3/4 of the children had seats in the stalls. So it's quite a tricky question because there's a lot that you need to extrapolate from here. But if 3/4 of the children had seats in the stalls, that must mean that 1/4 of the children had seats in the circle. So I know that 1/4 is equal to 117. So if 1/4, and again I can show this pictorially, if 1/4 is 117, then I know that 3/4 must be 3 times 117. So 3 times 117 gives me 351. So I know that in the stalls there are 351 children. So that's 351. There are exactly 2,600 seats in the theatre. On this Saturday, were there more people on more than 60% of the seats? So let's deal with that in a little bit. First of all, let's go with the information I've already been given, which is the ratio of adults to children is 5:2. So the total amount of children, if I do 117 plus 351, that's 468. So I know there are 468 children. So the ratio, I could draw this in parts to make it easier. So I know that adults to children is 5:2. So 1, 2, 3, 4, 5 parts to 2 parts. And I know that these 2 parts must make up 468. So what I can do is do 468 divided by 2 to figure out what 1 part is. So 234 is 1 part of my ratio. So that's 234. And that means that each part over here is also going to be 234. So if I've got 5 parts that are worth 234, I can do 5 times by 234 to work out the total amount of adults, which is 1,170. So now I've got some key pieces of information. I know in total there are 468 children and that there are 1,170 adults. So in total, how many people were there? Well, in total, I would do 468 plus 1,170, which gives me plus 468, 1,638. The question says that there are 2,600 seats, and I need to know if there were people on more than 60% of the seats. So I could write this as a percentage. To write anything as a percentage, you write the number. So there's 1,638 people out of the total, which is 2,600, and then I multiply it by 100. So 1,638 divided by 2,600 times by 100 is 63%. So I know there are people on 63% of the seats are occupied. So yes, because 63% is greater than 60%. Okay, so in this question, I'm being asked to describe fully the single transformation that maps shape A onto shape B. So common mistakes people make is that they write more than one transformation, and also they accidentally start from shape B. So single transformation means it's either going to be a reflection, a translation, or a rotation. Now, because the shape is in the same position, it's just switched over, it's going to be a reflection. It can't be a translation, because if it's a translation, it's moved, and so therefore it has to look exactly the same. And a rotation also is going to change the way the shape is facing. So it's a reflection. And when you say, it's asking you to describe the transformation fully, so you'd say it's a reflection, and then we need to find the line of reflection. So let's look at the distance between the 2 points. So we've got 1, 2, 3, 4, 5, 6. So the line of reflection, or the line of symmetry, is the halfway point. So halfway between these 2 points is 3 coordinates across. So that must mean it's a reflection in the line. Now there's a few ways we can call this. So you could call it the y-axis, or you could call it the line x equals 0, because if we're talking about lines of reflection, this line is when all of the x coordinates are always going to be 0. So that's 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So just saying it's a reflection in the line what x equals 0, or a reflection in the y-axis. Both are the exact same thing. The y-axis is when the x coordinate is 0. So yeah, for reflection, look for the halfway point. Okay, so I realised I accidentally missed question 18, so let's go through that one. So this is a set notation kind of question where there's just a few things that we need to know. So when you've got something like this, it's basically saying that the members, or the things that can exist in set A, these little brackets, they tell you what the conditions are. So for A to be a part of the set A, you need to be a multiple of 5 and a number that's between 14 and 26. So we can think of, what are the multiples of 5? We've got 5, 10, 15, 20, 25, 30, and so forth. And which of these are between 14 and 26? Well, 15, 20, and 25. So the members of set A would be 15, 20, and 25. In order to be part of the set, you need to be a multiple of 5, and you need to be between 14 and 26. So the members of set B are the odd numbers between 14 and 26. So what are the odd numbers? We'd start with 15, then 17, 19, 21, 23, and 25. So the only possible way you could be a member of set A is if you were 15, 20, and 25. And the only possible way you could be in set B is if you're one of those numbers. So now I'm being asked to list the members of A union B. So this little sign here means the union. And if you were to have a Venn diagram to show this, it would be everything that is in set A or in set B or in both. So what you want to do is say, okay, the members of set A, you've got 15, you've got, and we'll just do it not chronologically, in ascending order. So you've got 15, then you've got 17, then you've got 19, then you've got 20, then 21, 23, and finally 25. So I only have to write 25 and 15 once, because there's no point in writing them twice. I don't want to double down on myself. So 15 appears in both of them, and 25 also appears in both of them. I only need to write that once. So the union essentially means what is in set A or set B or both. So essentially every single number that is in set A and set B and anything that's in both of them as well. So all of these numbers is everything that is included in set A and B. Then I'm told to describe the members of A, and this sort of thing is the intersection, which if I had a Venn diagram and I've sorted my numbers out, it's just the things that are in A and B, literally the things that appear in both A and in B. So the members that are in set A and B. So that selection is a lot smaller. So using this, I've already circled actually the ones that are in A and B, and that would be 15 and 25. And it says describe the members of A and B. So what are these? Well, set A is the multiple, so any old multiple, whereas these ones are the odd multiples of 5. That's quite a tricky one that they're asking you to describe it, and notice that. Okay, next we've got a standard form question. So this is a calculator question, so we can just type it into our calculator. So you use the fraction button, you type it in 2.645 times, and if you don't know how to do the power of, you press that button there where it's like a box and then a thing on top of it, and we write 10, use the arrow, go to the power of 9 over 1.15 times 10 to the power of 3, which gives me 2, 3, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros. So that's 2,300,000. Now to put something in standard form, I write it as a number between 1 and 10. So that would become 2.3. And then times by 10 to the power of 1, 2, 3, 4, 5, 6. You'd be fine. Okay, so now we need to draw a frequency polygon for the information. So the frequency polygon, we always plot it against the midpoint. So that was where the midpoint would have been helpful. So over here, we're going to do the first one. It's 135 and 4. And first I want to check my scales. So this is 0 to 10, and there's 10 boxes. So I know that one box is worth 4. So I'm going to plot it at 135 and 1, 2, 3, 4. Then I've got 145 and 11. Then the midpoint is 155 and 24. And then I've got 165 and 22. And then finally 175 and 19. So when you're doing a frequency polygon, you do join the lines together. And just the ones like that are shown. Some people for some reason join it together like that. You don't do that. You just start from the first point and you join all of your points together. Okay, next we've got a speed question. So Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. So his average speed from Liverpool to Manchester was 70 kilometres per hour. And he took 75 minutes to drive from Manchester to Sheffield. So I need to work out his average speed for his total drive. So just a quick recap, to work out what speed is distance divided by time. If we ever forget it in the exam, you can think to yourself, what's the national speed limit? Well, it's 70 miles per hour. And what does the 70 represent? That represents the speed. What does miles represent? Well, miles is a form of distance. Per, what does that mean? It means divided by, so over. And hours is a measure of time. So that's just a quick way you might find it helpful to remember that formula. So let's look at how we can use that. Speed is distance divided by time. For the first part, I know he drove. So if I have my formula, I know that his average, so for part 1, from Liverpool to Manchester, I know that his average speed is 70. So in this formula, speed equals distance divided by time, I can fill out the information I know. So I know that the speed is 70, the distance is 56, I just don't know what the time is. So I could rearrange this equation. When I need to rearrange it and the subject is my denominator, I can just swap them over, or I can do it bit by bit. So I could have said 70t equals 56, and therefore t equals 56 over 70. But either way, the time it took him would be 56 divided by 70, which is 0.8 hours. So I don't need to convert that into minutes yet, because when we're dealing with speed, distance, time, it's always best to use it in hours. So let's just write that key piece of information there. So from Liverpool to Manchester, I know that his speed is 56, distance is, his speed was 70, distance is 56, and the time it took him is 0.8 hours. Now I need to work out for part 2. So from Manchester to Sheffield, what do I know in my speed equals distance times time divided by time? So I know that it took him 75 minutes to drive. So this is where it gets a little bit trickier. So we always want to write our time in terms of hours. So 75 minutes, I want to convert into hours. So to do it, to convert minutes to hours, what I do is I divide by 60, because there's 60 minutes in an hour. So 75 divided by 60 is 5 over 4, which is 1.25 hours. So I know that, 1.25 hours. And I also know that the distance is 61. So the speed is going to be the distance, which is 61, divided by the time, which is 1.25. So his speed is 61 divided by 1.25, which is 48.8 kilometers per hour. So I've got all of this information, and now I need to work out, I'll just write it here. So that's Liverpool to Manchester, and then I've got Manchester to Sheffield, where the speed is 48.8 kilometers per hour. Distance is 61 kilometers, and the time is, what did I say, 75 divided by 60 is 1.25. So I need to work out his average speed, and to work out the average speed, it's not just work out the two speeds and then divide it by 2. To work out the average speed, you need to know the total distance divided by the total time. So the total distance is going to be 56 plus 61. So 56 plus 61 divided by the total time, which is 0.8 plus 1.25. So 56 plus 61 is 117, and 0.8 plus 1.25 is 2.05. So I just type that into my calculator. 117 divided by 2.05 gives me 57.0731, which I would round to, it doesn't tell me, but I would just probably round it to 1 decimal place. So 57.1 kilometers per hour. So this is quite a tricky question, just for 1 mark, but it's saying Jenny drove from Barnsley to York, and her average speed from Barnsley to Leeds was 80 kilometers per hour, and her average speed from Leeds to York was 60 kilometers per hour. Now she says that the average speed from Barnsley to York can be found by working out the mean which means adding 80 plus 60 together and dividing by 2. If Jamie is correct, what does this tell you about the two parts of Jamie's journey? Well, in order for her to be correct, and the reason we can't just work out the average speed by adding up the speeds together and dividing by 2 is because generally there's a different length of distance and a different length of time. So we need the total distance divided by the total time. So the only way that Jamie could be correct is if the time taken for both journeys was the same. But it's quite an in-depth question to really understand it properly. Amy and Josh use a calculator to work out 595 divided by 4.08 squared plus 5.3. Amy's answer is 27.1115. Josh's answer is 271.115. One of these answers is correct. Use approximations to find out which answer is correct. So it's always really good to actually just estimate what the answer to your calculation would be, because calculators, sometimes you enter things wrong and they just tell you the wrong thing. So 595, I could round to 600. When you approximate or estimate, generally you should round to one significant figure. So 600 to 595 to one significant figure is 600. 4.08 I would round to 4, and 5.3 I would round to 5. So 600 divided by 4 squared. 4 squared is 16. 16 plus 5 is 21. So 600 divided by 21. Now you could use this, or you could then also approximate to turn it into, that would be approximately 600 divided by 20. So then we could just divide by 10, which would be 60 over 2, which is 30. So if I know that the answer should be roughly 30, I know that Amy is correct, because in terms of place value, 30 is a lot closer to 27 than 271.1. Okay, so here's an exchange rate question, and in these questions it's important to kind of decide what your end goal is. So I'm told that in London 1 litre of petrol costs 108.9p. So in London I know that 1 litre is 108.9 pence. I want to be able to get the same comparison for the US. So I want to find out, in the US, 1 litre is equal to how many pence? That's my end goal. I could also have done, in the US, 1 gallon is $2.83, and therefore worked out what London pricing for that would be. But I'm going to just go with London's pricing, because I'm in London. Okay, so where can we start? So first of all, I know that 1 US gallon, so 1 gallon costs $2.83. And I know that 1 gallon is equal to 3.875 litres. So therefore, I know that 3.785 litres costs $2.83. Now what I could do is try and figure out what 1 litre is. So to get from 3.785 to 1, what do? I'd have to divide by 3.785. So I'd need to do the same on this side too. So $2.83, 2.83 divided by 3.785 gives me 0.7476882431 cents. So I know that £1 is equal to $1.46. I have 74 cents. I'm not going to write all of it out, it's saved in your calculator. So how do I get from dollars to pounds? I need to divide by 1.46. So to get from dollars to pounds here, I'm going to divide by 1.46. Again, the real good thing is when you're doing conversions, list the facts that you know. So you know £1 is $1.46, and use the arrow to just think, okay, how to get from 1.46 to 1? I divide by 1.46. You're always going to divide by that thing to get to the 1 unit. So 0.747 divided by 1.46 is 0.512. That's quite cheap. So that's 0.5121152. So 1 litre costs, and that's in terms of pounds. So to turn it into pence, I'm going to times it by 100. So that would be 51.21 pence. Wow, that's quite the difference, half the price. So it's better value in London, in New York, as the price per litre is 51.21 pence versus 108.9 pence, almost half price. Okay, next question is an expand and simplify. So when I'm expanding brackets, expand means multiply out, and simplify is what we're going to do when we've expanded both brackets. So it's a single bracket, so I can put a dot above here. I'm doing 5 multiplied by p, which is 5p, and then I do 5 times by 3, which is 15. So doing the arrows just helps to remember what you need to do. So then we've got -2, and this is the bit that people often get wrong because they ignore the negative. Remember, the positive or the negative sign always belongs to the term after it. So it always belongs to the term after. Therefore, it's -2 I'm multiplying. So I do -2 times by 1, which is -2, and I do -2 times by -2p, and a negative times by a negative is a positive, so that would give me positive 4p. So I'd write positive 4p. So then, once I've expanded this, I can simplify. So when I simplify, I can bring together like terms. So anything that is the same letter and the same power, I can bring together. So I've got 5p plus 4p is going to give me 9p. And then I've got 15 take away 2, which is 13. So that's how I'd do that. Next, we've got a question with percentages. So Asmol is paid £1,500 a month. He's going to get a 3% increase in the amount of money he is paid. Work out how much money he will be paid per month after the increase. So what I need to do is work out what 3% of 1,500 is and add it on. So with percentages on the non-calculator, it's always helpful to just start by working out what 10% is. So 1,500 is equal to 100%. If I wanted to work out what 10% is, I would, or maybe I should switch these around. So 100% is equal to 1,500. To work out 10%, I would just divide by 10. The trick to work out 10% is always divide by 10. So 1,500 divided by 10 is 150. Now, if 10% is 150, to work out 1%, what do you divide 10 by to get to 1? You divide by 10 again. So 1% I divide by 10 would be 50. So I know that 1% is £15. I need to work out what 3% is. So what do I want to multiply 1 by to get to 3? I times by 3, and 15 times by 3 is 45. Or you could have done it like this. So 3 times 5 is 15, 3 times 1 is 3, plus the 1 is 4. So 3% I know is 45. His original salary was 1,500. He now gets £45 more, so that would be £1,545. Okay, over here I've got a transformation question. So I need to rotate trapezium T 180 degrees about the origin. Now the origin is literally the center over here. It's 0, 0. The origin is where everything begins. So I need to rotate T 180 degrees about the origin. And when I do this, you get some tracing paper. And when you rotate, you always go clockwise. In this case, it doesn't matter because 180 will take you both ways. But you put your tracing paper. So this can be your tracing paper. You get your pencil and you draw over this shape. Then you put your pencil here and you rotate the paper. So if this is how your paper starts off, when you rotate it, it's going to look like this because you're rotating it clockwise. That's a 90 degrees rotation. When you rotate it again, it's going to look like this. That's going to be a 180 degrees rotation. So when you've done that with your tracing paper, you want to generally, the safest way is, some people are really good at remembering, but you might want to just note down where the new points take you. So your trapezium on your tracing paper, you should see this outline here and you'd be like, okay, so one of the coordinates is -2, 1. Let me write that down. The next one is -2, 2. Then you've got -4, 1. And then -5, 2. So write down your coordinates and then you can draw your lane shape on. So let's label the trapezium A. The next question is saying translate. So translate, that means move it through the vector, and it's telling us the vector -1, -3. So your vector is a movement and your top part of the vector is the movement across. So your x coordinate, or how much it moves across along the x-axis, and the bottom number is how much it moves up or down. So if it's going left, it's going to be negative. If it's going down, it's going to be negative. If it's going right, it's going to be positive. If it's going up, it's going to be positive. So I've got -1 for my top x movement. So that means 1 to the left. So negative means I'm going to the left. And I've also got a -3. So that means 3 down. So what I do is I can pick any point of my trapezium. I can just pick this top point. I know I need to move, it's going -1 and then moving down 3. So across 1 and then down 3. So I go across 1 and down 3, and that is where my new point would be. I can then just by looking at it, draw the whole trapezium, or I could do it point by point. So over here I go across 1 and down 3. Same here, I go across 1, down 3, across 1, down 3. And that's how you translate a shape. So it's really important that you know that the top value is your x movement, how much it moves across. If it's negative, left, positive, it goes right. And the same for the up. Okay, over here we've got some index laws. So the key thing that we need to know is when we're multiplying indices, so let's say you've got 2 squared times by 2 to the power 3, that ends up being 2 to the power 5. But why does that happen? When I am multiplying indices, I always add the powers together. I mean, 2 squared means 2 times 2, 2 cubed means 2 times 2 times 2. So in total, 2 is being multiplied by itself 5 times. That's what this little power means. It means how many times your base, the big number, is being multiplied by itself. So here I'm multiplying my indices. So I know that p to the power of 3 times by p to the power of x. What am I going to have to do when multiplying indices? You add the powers. So what would I have to do? that would become 3 plus x. I don't know what x is, but I know that p to the power of 3 plus x is the same as p to the power of 9. So I can then form an equation. I know that 3 plus x must be equal to 9. So 3 plus something equals 9. If I take 3 from both sides, x is 6. So this is quite a tricky question, but it's about using the laws of indices that you already know, or if you didn't, then familiarize yourself with them and applying them. And then a little tricky bit, recognizing that they must be equal. The same thing here, when you're multiplying indices. So let's say I had 7 squared, times by 3. That would become 7 to the power of 6, because when indices are in brackets, this is the law of brackets, you multiply the powers. The powers are just the little numbers. So that means 7 squared to the power of y would become 2 times by y, which is 2y. So I know that 7 to the power of 2y is the same as 7 to the power of 10. So therefore, 2y must equal 10. And if I divide both sides by 2, y equals 5. You could also have maybe just done that without drawing these equations. If you know the laws of indices, you're like, okay, I know that I'm going to have to do 3 plus something to make 9, 3 plus 6. And over here, I know I'd have to do 2 times something to make 10. But this is the reasoning bit for it. Okay, show that 100 to the power of a times by 1000 to the power of b can be written in the form 10 to the power of w. So this is quite a difficult question. There's no two ways about it, but let's have a think about what's going on. We've got 10 to the power of w. That's how we want to write it. We want to write this and this in the form 10 to the power of something. So how could I write 100 in terms of 10? I know that 10 times 10 makes 100, and to write that in index form would be 10 squared. So 100 to the power of a is the same as saying 10 squared to the power of a. All I've done is I've rewritten 100 as a power of 10. And using the laws of indices, what do I do when indices are in brackets? I multiply them. So that would become 10 to the power of 2a. So all I've done is I've rewritten 100 to the power of a as 10 to the power of 2a. Now I want to do the same with 1000. So 1000, well, let's just do 1000 first. 1000 is the same as 10 times 10 times 10, which is the same as 10 cubed. So the trick here is looking at it and being like, okay, how can I write 100 as a power of 10? How can I write 1000 as a power of 10? So 1000 to the power of b is the same as saying 10 cubed to the power of b. And once again, what do you do when you multiply indices? Indices are in brackets, you multiply them. So that would become 10 to the power of 3b. So 100 to the power of a times by 1000 to the power of b is the same as saying 10 to the power of 2a, following this route, times by 10 to the power of 3b. So therefore, if I write that out like this, I know that 10 to the power of 2a times by 10 to the power of 3b is equal to 10 to the power of w, because what happens when you multiply indices, you add the powers. So that would become 10 to the power of 2a plus 3b is equal to 10 to the power of w. And then what do? I know that this must be equal to that, so therefore w must equal 2a plus 3b. This is a tricky question, but that's how we'd show that. So we'd show, Okay, so next it says the table shows information about the weekly earnings of 20 people who work in a shop. Work out an estimate for the mean of the weekly earnings. Now, the reason we say an estimate is because with these questions, we always have a range. So here we know that one person has a weekly earning of between 150 and 250 pounds, but we don't know the exact value. So what we do, if we ever have to work out the mean from a grouped frequency table, the first step is that we want to work out the midpoint of our class intervals. So I'm just going to write a little column, a little thing for the midpoint. So I want to work out halfway between 150 and 250, which is 200. If you didn't know how to work out the midpoint, you just add the two values together. So 150 plus 250, and then you divide by 2. So 150 plus 200 plus 200 is 300, 50 plus 50 is 400, so that would be 400 divided by 2. So you can do it that way, or you might just be able to look at it and find the midpoint. So the midpoint here would be 300, 400, 500 and 600. So that's step one. Then what I do, now that I have found my midpoint, in my final column, oops, I did the times is in the wrong place. In my final column, what I can call this column is the midpoint times by the frequency. So what I do is I multiply my frequency by my midpoint. So 1 times 200 is 200, 11 times 300, so 11 times 3 is 33, so 11 times 30 would be 330, and 11 times 300 would be 3,300. So we can do it like that. 5 times 400, so let's do it the same way. 5 times 4 is 20, times by 10 is 200, times by 10 again is 2,000. Or you could just do 5 times 4, which is 20, and then add on the 2 zeros. So that's 2,000. 0 times 500 is 0 times by anything is always going to be 0. Because if no people earn between 450 and if no people earn £500, then no money is earned. And then 3 times 600, so 3 times 6 is 18, and then add the 2 zeros, so 1,800. So once you've done this column, to work out the mean, what we do is we add up the value of all of this final column, because what I've done is I've essentially said, okay, 11 people earn £300, so in total 3,300 pounds has been earned. So I add up the total money earned. So the mean is going to be the total of your midpoint times frequency column divided by the frequency. And the frequency is always going to be your second column, and you are actually told what the frequency is. Frequency means that it's always in context. In this question, it would be the number of people, but it might be the number of points scored or whatever. Frequency just means the total amount. So I know that this total over here is 20, and all I need to do is work out what this total here would be. So let's add everything together. I'll just start with the largest numbers and put them in order of size. So I'm adding 3,300 plus 2,000 plus 1,800 plus 200. So 0 plus 0 plus 0 is 0, 0. 8 plus 2 is 10, plus 3 is 13. 3 plus 2 is 5, 6, 7. So the total is 7,300, and I'm going to divide that by 20 because that is the frequency. So what I can do now is just simplify my fraction. So if I divide by 10, that would be 730 divided by 2. And because I've simplified it to a nice little fraction now, what I can do is just use the bus stop method to help me out. So 730, that total was here, divided by 2. 2's into 7 go 3 times, remainder 1. 2's into 13 go 6 times, remainder 1. And 2's into 10 go 5. So an estimate for the mean of the weekly earnings is 365. You can always sense check your answer as well, because if, like, for instance, your answer was £3,650, does that make sense? The mean is like the average, and nobody earns more than £650 per week, so you know that 3,600 is way off. Similarly, if you maybe accidentally got £36.50, does that make sense? Because the lowest anyone earns is 150. So always double check your answers just by using common sense. Okay, so now I'm being told that Nadia says that the mean may not be the best average to use to represent this information. So you've got three averages. You've got your mode, your median, and your mean. So the mean, she's saying, might not be the best average. So I need to think, what would the other two averages offer me, and what is that doing? So when I have the mean, I'm essentially adding all the scores together and dividing by the total number. So it gives me like an average. But if I have all of my data skewed to one end of the spectrum, then it skews the data quite a lot. So as you can see over here, 11 out of the 20 people, so that's over half, earn less than £350. And they said that the average is £365. So if 11 people are earning, let's say £255, that's inflating their wage. So what can the other averages offer me? Well, the mode is the most common. So if I use the mode, that would say that the average weekly wage is between 250 and 350. Or I could use the median. So if I use the median, then I've got one person, which is over here. To work out the median, what you do is you have your frequency, which is 20. You add 1 and then you divide by 2. So 21 divided by 2 is 10.5. So the 10.5 value would tell you the median. And the 10.5 value would land in this interval here. So both the mode and the median tell me, both the mode and median suggest that the average wage is between 250 and 350 pounds, which is less than what the mean suggests. The mean takes into account all of the values, and so can skew the data. In this case, it's inflated it because there's 3 people that earn potentially £650, so that makes it seem like everyone in the company is earning more. Okay, next we've got a percentage profit question. So I'm told that Renee buys 5 kilograms of sweets to sell, and that she pays £10 for the sweets. She puts all the sweets into bags, and she puts 250 grams of sweets into each bag. She sells each bag of sweets for 65p. She sells all of her bags, and I need to work out her percentage profit. So we spoke a little bit about profit earlier on. Profit is the selling price, take away any costs. So like the cost to buy the item, or the cost to paint it, or whatever you do to it. So first of all, let's work out her costs. So I know that she buys 5 kilograms of sweets and she pays £10 for that. And then she puts all of the sweets into 250 gram bags. So I know that 5 kilograms is £10. I could then work out what 1 kilogram must be. So 5 divided by 5 gives you 1. So I'm going to do the same to this side. So 10 divided by 5 is £2. And I know, well, I might not know, but 250 grams, I could go up in my 250s. Then I've got 500 grams, 750 grams, then 1000 grams, which is 1 kilogram. So I know that 4 lots of 250 grams fit into 1 kilogram. So I divide by 4 to figure out what 250 grams must cost. And 2, or 200 pence divided by 4 is 50 pence. So I know that her costs are 50 pence per bag. And then her selling price is 65 pence per bag. So how do I work out percentage profit? So percentage profit, the formula for percentage profit is your selling price, takeaway costs over your costs times by 100. So let's do this over here. What is the selling price? It's 65 pence. The costs are 50 pence. And the costs are 50 pence again. So 65 take away 50 is 15. So I'd be left with 15 over 50 times by 100. Now I'm going to need to do a little bit of simplifying to make my life easier. So I know I've got 15 over 50 times by 100. And it depends actually like what your maths numeracy is like as to what you're going to find easier. Probably the easiest thing would be to simplify 15 over 50. So let's start by dividing by 5. So 15 divided by 5 is 3. 50 divided by 5 is 10. So that becomes 3/10 times by 100. And 3/10 times by 100, we'd just turn that into a fraction. 3 times 100 is 300. And 10 times 1 is 10. So you'd be left with 300 divided by 10. If you, to divide both numerator and denominator by 10, we just chop off the 0. So that becomes 30 over 1, which would become 30%. So her percentage profit is 30%. Next, I've got a ratio question. So I'm told that there are only blue pens, green pens and red pens in a box, and that the ratio of the number of blue pens, so blue pens to green pens, is 2 to 5, and that the ratio of the number of green pens to the number of red pens is 4 to 1. So what I do is I've been given 3 types of pens, but I've been given 2 separate ratios, and I'm going to somehow try and combine them. So I'm told that there are less than 100 pens in the box, and what is the greatest number of red pens in the box? So to do this, I'm going to need to use my equivalent ratios. So I can see that I have my green is in common. So I want to find the lowest common multiple of 5 and 4, which is 20. Because if I have my green in the same ratio, then I can get equivalent ratios for everything else. So if I multiply this by 4, that would get me 20. So 2 times 4 is 8, 5 times 4 is 20. And what would I have multiplied 4 by to get to 20? I would have multiplied it by 5. So I multiply 1 times 5 as well. So now, because effectively what I've done is I've said blue to green is 2 to 20 and green to red is 20 to 5, because I have a common thing, I can combine all of them. So I can combine blue to green to red, I know is in the ratio of 8 to 20 to 5. So what's the greatest possible number of red pens in the box? Well, in total, I know that I've got 20 plus 8 plus 5 pens each time I'm sharing them out. So 20 plus 8 plus 5 gives me 33. And how many times can 33 fit into 100? If I did 100 divided by 33, that would give me 3.03. So I know that 3 full sets of this ratio partition are going to fit into 100. So the number of red pens is 5. So I know I can times that by 3, times everything by 3. And I'd end up with 15 red pens would be the maximum amount of red pens, because if I did this ratio, say I split it, another way that you could have done it is just thought to yourself, okay, so if the ratio is for every 8 blue pens, there are 20 green pens and 5 red pens, double it. So the next time you split it, you know, it would be 16 to 40 to 10. Add on another set of the ratio, that would be 24 to 60 to 15. So you're just, each time you split in a ratio, you need to make sure that you're divided. Okay, next I've got a probability tree. So I'm told that when a biased 6-sided dice, and biased means that it's not fair, it's not like a normal, something's happened to it, like a weight has been put on it to make it land on one side more times than the other side. So when a biased 6-sided dice is thrown once, the probability that it will land on 4 is 0.65. The biased dice is thrown twice. Amir draws this probability tree diagram, and we're told that the tree diagram is not correct. So I'm told to write down 2 things that are wrong with the probability tree diagram. So the first thing about a probability tree diagram, and just probability in general, when you've got mutually exclusive events, which means two things that cannot happen at the same time. So for instance, the dice can't land on a 4 and also land on a 5. It can only land on one side at once. So the probability that it lands on a 4 or not lands on a 4 must add to 1. So probability must always add to 1 when we're dealing with mutually exclusive events. And 0.65 plus 0.25, if I add that, does that add to 1? So 0.65 plus 0.25 gives me 0.9. So 1, the first branch is incorrect. Probability should add to 1. So therefore, if I know that this is definitely correct, this is going to need to be 0.35. The not land on 4 should be 0.35. And then the second thing that is wrong is each time it's thrown, probability renews. So the fact that it should land on 4 should always be 0.65. So this bit here is wrong. So the way you could word it is on the second throw, 0.35 should remain as 0.65 because the probability is the same. So there's, yeah, he's just made a few silly mistakes, so that's wrong. And these two should be swapped around. Okay, so here I've got an error interval question. I'm told that a number n is rounded to 2 decimal places and the result is 4.76. So if I write 4.76 here, and I think to 2 decimal places, what could it round up to? That would be 4.77. And what could have it rounded up from? That would have been 4.75. And I want to find the midpoint. So 4.755 is the lowest it could have been before it would have rounded down to 4.75. And 4.765 is the largest it could be before it would have rounded up to 4.77. So I'd say that 4.755 is less than n, which is less than or equal to 4.765. Oh, sorry, I got that the wrong way around. So 4.755 is less than or equal to n, because if it was 4.755, it would round up to 4.76, the 2 decimal places, and it has to be less than 4.765, because if it was actually 4.765, it would round up to 4. Okay, now I'm told that Jess rounds a number x to 1 decimal place, and the result is 9.8. And I need to write down the error interval. So what I want to do is think to myself, okay, so 9.8 has been rounded, And if it's been rounded, what are the decimal places it could have either rounded up or down to? So it could have rounded down, my number could have rounded down to 9.7, or it could have rounded up to 9.9 because I'm dealing with one decimal place. So I'm just looking at the decimal point. So what is the minimum number that it could be before it would have rounded down to 9.7? So 9.75 is the midway point, and 9.85 is the midway point between my two decimals. And if it was 9.74, for example, so 9.74, it would round down to 9.7. So 9.75 is the lowest value it could be in order to round up to 9.8. And similarly, the highest technical value it could be would be 9.8499 going on until infinity. But because I'm doing an error interval, I can just say that 9.75 has to be less than or equal to x, because it could be 9.75, that would still round to 9.8, but it has to be less than 9.85. So instead of writing 9.84999, I just say it can be anything up to 9.85. So an error interval is where you think, okay, what numbers could it possibly have been? It's in between these two values, could be anything in between them, and that's how I'd write my error interval. You always write it as less than or equal to the minimum number, and then less than. Then it says the value of Rita's house increased by 5%. The house then had a value of 210,000. So her original value was 100%. I don't know what that is, but I know that 105% is equal to £210,000. So what I can do is I could figure out what 1% is. So if to get to 1 from 105, I have to divide by 105. So I do the same to this side here. So 210,000 divided by 105 is 2,000. So 1% is 2,000. And then to get to 100%, I multiply 1% by 100. So I have to do the same to the other side as well. So that would be 200,000. And that would be the value before the increase. And that's the end of the paper. Next, and this is a slightly trickier bit, we need to work out the total surface area of the pyramid. So surface area is where you work out the area of each face individually and you add them together. So it's a solid square based pyramid. So if we think about the net, like if we unfolded it, it would have these 4 triangles on either side. And if we folded them back up, they'd make the pyramid. So it's kind of like, is there a sweet that is in this shape? I feel like they do some Christmas sweets that are in this shape. I can't think of the name. Anyway, what we need to do is therefore work out the area of each of these shapes. So it's a square based pyramid. If it's a square, that means that the base is going to be, I know this side is 6 centimeters. So I know that this side here is also going to be 6 centimeters because the whole point of a square is that its sides are equal. So this is going to be 36 centimeters squared. That's the easy part. The next part is I'm going to have to work out the area of these triangles. So how do you work out the area of a triangle? Well, you work out the vertical height. So area of a triangle is base times by vertical height, or perpendicular height, you might call it, divided by 2. And it's very important we think very carefully about what height we're talking about. So in this triangle, they've given me this slant height here. And if I looked at that triangle face on, that would essentially be the vertical height because it goes from the center of the triangle to the top of it. So the base of the triangle must be 6 centimeters because it's still my square based pyramid. And then the height, the vertical height, is 5 centimeters. So for the area of the triangle, I would do 6 times by 5 divided by 2, which is 30 divided by 2, which is 15 centimeters squared. So it's a surface area, which means I need to work out the area of each part. And because it's a square-based pyramid, it means that each face is going to be equal. So I've got 4 equal triangles that are 15 centimeters squared each. So I could label it here. So that's 15, that's 15, that's 15, that's 15, and that's 36. And then I add them all together. So 15 times by 4, I could do first. So 15 plus 15 is 30. Double that is 60. So I've got 60 plus 36, which is 106 centimeters squared. So this one was quite a tricky one. But yes, surface area just means work out the area of each of the faces. So imagine you were wrapping it. What are all of the faces? What are all of the sides that you're going to have to wrap and work out the area? Or you could imagine like dipping the whole thing into chocolate or honey or something, and like the area that the chocolate and the honey are going to cover. And when I said 60 plus 36 was 106, what I actually meant to say was 96 centimeters squared. So even if you are really good at maths, mental maths is always, especially if you're doing a lot of things, it's helpful to just actually do the working out, because you can make silly mistakes like I have just. In this question, I am told that the area of square ABCD is 10 centimeters squared. So how do you work out the area of a square? You do base times height. So I know that 3 plus x, which is the length of this square here, times by 3 plus x must equal 10 centimeters squared, because whatever my length is here times by my other length is going to give me the area. It just so happens that this is a slightly more complicated length. Now I need to show that x squared plus 6 equals 1. So there's a few ways I can do this. First of all, what I could do is I could work out the areas of the individual bits of the square. So over here, this area is going to be 3 times by 3, which is 9 centimeters squared. Then I could work out the area of this bit here. So that's x times by 3, because if that length here is 3, this length here would also be 3. So that would be 3x. Then here, that's x, that length here is also 3, so that would also be 3x. Or over here, I'd have x times by x, so that would be x squared. And then what I could do is write them all out. So I could say 9 plus 3x plus 3x plus x squared must equal to 10 centimeters squared, because that's what they've told me. So this is the area in here, and it must equal 10 centimeters squared. I could simplify that. So 3x plus 3x would be 6x. So 9 plus 6x plus x squared equals 10. And then I could rearrange it so that it's in order of powers. So x squared plus 6x plus 9 equals 10. All I've done is I've just moved them around so that they're in order. And now if I subtracted 9 from both sides, I'd be left with x squared plus 6x equals 1. So that's the first way that I could do it. The other way would have been the way we started off originally, which is by showing that the length would have been x plus 3, and therefore the other length would have been x plus 3 as well, and expanding my brackets. So I would have done x times by x is x squared, x times by 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. I would have then simplified it again, just like I did before, made it equal to 10, because that is what the area is, and rearranged it to get 1. So this is a slightly unusual question in that it's not just telling you to expand the brackets, it relies on you to realise that you could write this here as a length like that, or you could have even written it as 3 plus x, it doesn't matter. But recognising that this times by this would give you the area, and then rearranging it and simplifying. Next, I've got a little fun equation forming question. So with questions like these, when you're given some information but you're not given the exact values, always just the easiest way is to use algebra. There are a lot of people that have done this using trial and improvement, it's just a lot longer. So I'm told that Chiara is 7 years older than Jay. Okay, so I don't know how old Jay is, but I know that however old he is, that Chiara is 7 years older than him. So what I'm going to do is Jay is my patient 0. I'm going to call him X. I don't know how old he is, but I do know that however old he is, Chiara is 7 years older than that. So I can then form an expression. I'm then told that Martha is twice as old as Chiara. So Martha is 2 lots of whatever Chiara is. So Chiara is this expression here. So I'm going to say 2x plus 7. I could expand the brackets just to make my life easier. So 2 times 2, 2 times x is 2x, and 2 times by 7 is 14. So I now have an expression for all of their ages. And I know that the sum, that means add, of their 3 ages is 77. So I know that x plus 7. Okay, so I'm writing out all of the expressions for their ages, plus 2x plus 14 must equal 77. So I've got this nice equation that I have formed, and now I can simplify it. So let's collect all the like terms. So I've got x plus 2x. So that would give me 4x. And then I've got 7 plus 14, which is 21, must equal 77. Now I've simplified this equation. What I want to do is solve it to find the value of x. So once again, I put my finger over x, and then I think what else is on this side? I've got a positive 21. So I'm going to subtract 21 so it cancels on this side. And whatever I do to one side, I have to do to the other to keep the equations balanced. So I'm left with 4x equals 77, take away 21, 7 take 1 is 6, 7 take 2 is 5. So 4x equals 56. So 4 is being multiplied by x. So what I'm going to have to do to cancel that is divide both sides by 4. So now I have to do 56 divided by 4. 4s into 5 go once, remainder 1, and 4s into 16 go 4. So x is 14. So if I know that x is 14, then let's start with J. I know that the expression for his age was x, so J is just 14. Martha is Chiara is 7 years older, so 14 plus 7 is 21. And, oh my God, I'm writing this all wrong. Sorry, that was Chiara. And then Martha is twice as old as Chiara, so that would be 42. Find the ratio of J's age to Chiara's age to Martha's age. So all I'm going to do is just write out their names. So I've got J to Chiara to Martha. And J is 14, Chiara is 21, and Martha is 42. So the ratio of the ages is 14 to 21 to 42. It hasn't asked me to simplify them. Factorising is the inverse of expanding. And to factorise something, all we do is we're looking for the factors of the last thing in my quadratic. So factors of 9 would be 9 times 1 and 3 times 3. Factors are the numbers that multiply together to make them. And then what we want to do is, out of these factor pairs, decide which of them add to make my middle term. So 9 plus 1 is 10, 3 plus 3 is 6. So I know I'm going to use these two factors. Now what you do is you have the factor of 3 and the factor of 3. You put it into brackets and you're going to write x, and it's a positive 3, so you're going to write x plus 3, and over here x plus 3. So that's how you factorise, you putting it into brackets. You can always double check by expanding. So x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9. Simplify it, x squared plus 6x plus 9, so you know you've done it right. But this is you expanding the bracket out. The answer is x plus 3, x plus 3. Factorise just means put it into brackets. And that's the end of that. Next, I've got angles on parallel lines, and I'm told that ABCD is a parallelogram, which means that I've got parallel lines here and here. And you can also identify parallel lines because the little arrow, it tells you that those lines are parallel. So I know that AB is parallel to DC, and that AD is parallel to BC. I know that EDC over here is a straight line, so that would be a transversal, which essentially just means a line that cuts through the parallel lines. And F is the point on AD, so that BFE is also a straight line, so this is also going to be a transversal. So I can use all of my angles on parallel lines rules here. I know that this angle here is 35 and this angle here is 75, and I need to show the angle ABF. So ABF is this angle here. You always know, so basically if you don't know how to read the angles, you start from A, you go to B, and then you go to F, so you know it's the angle in between those. So I need to prove that that is 70. So there's a few things that I can do. So using my angle rules, whenever I have like a cross, so over here, hopefully you can see that there's a cross, I know that I can use the vertically opposite angle rule. So vertically opposite angles are equal. Therefore, I know that this angle here must be 35 degrees. Now, the next thing I could do is, if I know that that angle here is 35 degrees, then I know that this angle here, so over here I've got a straight line now, so I've got 35 degrees here, and this angle here form a straight line. So 180 take 35 would give me 5, 4, 1. So that angle here would be 145. I don't actually know if that's helpful yet, but sometimes you work angles out and you don't need them, but it's just helpful to just work out anything that you can. So I'm just trying to think which would be the easiest way. So I could work out this angle here, because when you've got parallel lines, you've got something like this where both angles are on the interior inside of the parallel lines and they're on the same side of the transversal, and they are called interior angles. And interior angles add to 180 degrees. So I know that 180 take away 75 would be 10 take 5 is 5, 7 take 7 is 0. So this angle here would be 105 degrees. So that would be a parallelogram. Now, if I turned my, so there's two things. So if you didn't know these rules, then just write them down, but I just need to make some space. So another thing that you should know from your quadrilateral facts is that opposite angles in a parallelogram are equal. So I could have just actually worked that out first. I just wanted to see if there was a route we could do without that. So I could have done that 75 degrees, or if you didn't know that fact, you also know that these two lines here, this line and this line, are parallel. So this angle and this angle here, if you just turn the page around, they would also be co-interior angles, so they would need to sum to 180. So there's two ways you could have got it, either because opposite angles in a parallelogram are equal, or the co-interior angle route. So now I've got this triangle here with an angle of 75, an angle of 35, and a missing angle. And I know that angles in a triangle sum to 180 degrees. So therefore, if I did 75 plus 35, that gives me 10, 8, 9, 10, 11, so 110 degrees. And the missing angle must be 180, take away 110, which is 70 degrees. So all of that working you need to write the reasons. So even the basic ones like angles on a straight line add up to 180. Any reason that you use in order to work out the missing angle, just write it down, because for angle reasoning, it's the reasons that they're looking for. So that's how we show that this would be 70 degrees. The final bit is angles in a triangle. Next, I've got an arithmetic sequence, which means that each term has a common difference. So the first thing I want to do is just think to myself, okay, how do I get from 3 to 8? I add 5. How do I get from 8 to 13? I add 5. From 13 to 18, I add 5. And 5 is the common difference. So whatever your common difference is, that's what times tables the sequence is going up in. So I'd write 5n because it's the 5 times tables. And if it was the 5 times tables, then it would be 5, 10, 15, 20. But it's the 5 times tables, but it's been shifted. Each term is actually 2 less. How do you get from 5 to 3? You take 2. From 10 to 8, you take 2. From 15 to 13, you take 2. So the sequence rule would be 5n, take 2. Next, it says the nth term of a different sequence is 3n squared. And what does 3n squared mean? It means 3 times by n squared. Nathan says that the 4th term of this sequence is 144. Is Nathan right? So if it's the 4th term, n represents the position of the number in the sequence. So like the 1st term, 2nd term, 3rd term, 4th term. So the 4th term, n would be 4. So I do 3 times by 4 squared. 4 squared is 16. And 3 times 16 is 48. So no, Nathan is not correct. Okay, next I've got a standard form question. So remember, you are allowed to use your calculator for this, so that makes it a lot easier. So I can just write this out like this and ignore the brackets for now because everything is being multiplied. So what I want to do is multiply these two numbers. So 13.8 times by 5.4 gives me 74.52. And then I can use the laws of indices for this. So when I'm multiplying indices, so 10 to the power of a times 10 to the power of b, that would become 10 to the power of a plus b. So in this case, 10 to the power of 7 times 10 to the power of negative 12. When I'm multiplying, I add the powers. So that would become 7 plus negative 12. And when you've got a plus and a negative next to each other, that just overwrites it as a negative, because when you're adding a negative number, it's the same as subtracting. So 7 take away 12 would give me negative 5. So that would be 10 to the power of negative 5. Now I need to give my answer as an ordinary number. So 72 times by 10 to the power of negative 5. If I type that into my calculator, it simplifies it to standard form, so that's not going to help you. So it tells you that it's 7.2. Oh, I wrote 72, I don't know why. So it's 7.452 times 10 to the power of negative 4. Now, when you're doing something to the power of negative 4, all that means is you want to move everything so that it's 4 places to the right. So if it's written in standard form, that's what we do. Just to quickly recap, if you're not super familiar with standard form, let's say I've got 10 cubed, that's 1,000. 10 squared is 100. 10 to the power of 1 is 10. 10 to the power of 0 is 1. 10 to the power of minus 1, following this pattern, each time I'm dividing by 10. So that would be 0.1. 10 to the power of minus 2 would be 0.01. To the minus 3 would be 0.001. And to the minus 4 would be 0.0001. So essentially, I'm multiplying 7.452 by 0.0001. When I'm multiplying decimals, you can literally multiply, you can turn everything into whole numbers. So that's the same as saying 7,452 times by 1. And then what your answer needs to have is however many decimal points, however many digits are after the decimal point in your calculation. So you've got 1, 2, 3, 4, 5, 6, 7 digits after the decimal point. So you know your number is going to have 1, 2, 3, 4, 5, 6, 7 digits after the decimal point. So you can start filling it out from the back. And then you add in the zeros for anywhere in front of it. So that's one way, or the other way is, you know it's to the power of -4. So you start writing your decimal after the 4th zero. So 1, 2, 3, 4 zeros, and then you start writing your number. So that's the two ways that we can do this. And an ordinary number, that just means like either a full decimal or a full whole number, no times 10 to the power of something. Next, I'm told that I have got two similar triangles. If the triangles are similar, it means they are multiplied by the same scale factor. So, for instance, this would be a similar triangle. Let's say that's 8. I'm like, okay, I know that this triangle is 4 times larger. So if this side was 6, this side would be 24. You'd multiply each side by a scale factor. So this first thing that we want to do is look for two sides that are corresponding, so in the same place in each triangle. So AB and DF are the same. So I know I need to figure out what I'm multiplying this triangle by to get to that triangle. And to work that out, I've got 12.6 here and 8.4 here. So I could do 12.6 divided by 8.4. This is going to tell me the scale factor. So 12.6 divided by 8.4 is 3/2. So that's 1.5. So I know that this triangle is 1.5 times larger. So I need to work out the length of DF. Where's DF? Over here. So I know the corresponding side over here is 6.4. I've worked out that the scale factor is 1.5. So I'm going from the smaller triangle to the bigger triangle. So I'm going to times by 1.5. And 6.4 times by 1.5 gives me 9.6. So it's going to be 9.6 centimeters. Then for the length of CB, it's this one here. I know it's 15 centimeters on the larger triangle, but to get from the larger triangle to the smaller triangle, I'm going to have to divide by the scale factor. So 15 divided by 1.5 gives me 10. So CB is going to be 10 together. Okay, so now I'm told to solve the simultaneous equations. So the key thing with simultaneous equations is the first thing you want, this is quite a tricky one, you want to have either your x or your y variables to be the same. So none of these are the same. This is the trickiest kind of simultaneous equation. So you first just decide, do I want to make my y values the same or my x values? I'm gonna go and make my x values the same. So in order to do that, this is x currently, I'm going to need to times it by 5 and then it will become 5x. But because I'm doing that, I need to do the same to each part of the equation. So this is going to become 5x plus 3 times 5 is 15y and 12 times 5 is 60. You can use a calculator to do this. And then I rewrite the other equation underneath. So I've got 5x minus y equals 4. Now that I've got one of the variables, in this case the x variables that are the same, I can subtract, I can eliminate it. So in order to eliminate it, I need to think, do I add or do I subtract? 5 plus 5 makes 10, so if I add, that's not going to eliminate. So I know that I'm going to have to subtract. And it's good to write out what you're doing just next to the equation there, so that you know that you do it to each part of the equation. So you've got 5x take away 5x, that cancels out to 0. Then you've got 15 take away negative y, and this is where it's really important to be good with your negatives. So when you've got two negatives next to each other in between your numbers, it becomes a positive. If you just think about it, if you're taking away a negative, essentially you're adding. So if you think about having like I don't know, ice cubes in soup, and you take out the ice cubes, the effect is that you're going to make it warmer because you're taking out the cold, you're taking out the negative. So subtracting a negative is the same as adding. So 15y, that was meant to say 15y minus 1y. So 15y take away negative y is the same as saying 15y plus y, which would give me 16y. And then 60 take away 4 is 56. So now I've just got an equation, and to figure out what y is, I'm going to have to divide by 16. So 56 divided by 16 is 3.5. So I know that my value of y is 3.5. Now, when I figured out one of my values, what I can then do is substitute back into the easiest equation to figure out what my x value must be. So it doesn't really matter which one you pick. We're just going to say y equals 3.5. And then let's have a go at substituting back into it. So when y equals 3.5, I'm going to just choose this one. 5x take away one lot of y, which would be 3.5, equals 4. And now I need to solve this equation to find out what x is. So I add 3.5 to both sides of the equation, and I'm left with 5x equals 7.5. I then have to solve it, so I'm going to divide by 5, and then x is going to be 7.5 divided by 5, which gives me 1.5. So to solve the simultaneous equations, you need two things. You need to have told what the x value is and what the y value is. So you just say x is 1.5 and then lastly, I need to work out the volume of a prism. Now, to work out the volume of any prism, whatever the shape is at the front, you can just work out the area of the front face and times it by the length. So that is the formula for any prism, and a prism is just a 3D solid that has a constant cross section. So it's like a Colin the Caterpillar birthday cake that has, however you slice it, it's going to give you the same shape. An ice cream cone is not a prism because it gets smaller and smaller and smaller. So a prism is if it's the same shape throughout. If you like pushed that shape throughout the shape, it would remain the same. And the face is the front, well, any of the outside bits would be a face, but we do the area of the front face times by the length. So that means I know that I need to work out the area of this triangle. Now, how do I work out the area of a triangle? I have to do base times by perpendicular height divided by 2. And this is where a lot of people are going to get caught out because they might use the slant height, which is the diagonal height. But when I'm working out the area of a triangle, I need the base and the height to be perpendicular, which means at right angles too. So that means I need to figure out what this is here. So I've got a triangle. I know what this side is. I know what this side is. And I need to figure out this missing side. So when you've got a triangle and you know two sides and you need the third side, you use Pythagoras. So Pythagoras' theorem states that a squared plus b squared equals c squared, and c is the longest length. So I know that this is going to be c. It doesn't matter whether this is a or b, it's the two shorter sides. So when you've got the longest side, you actually, in order to get this, we're going to have to subtract b squared. So we could rearrange it to say c squared minus b squared equals a squared. And in this case, c is going to be 8.4. So I do 8.4 squared, take away, let's let's just switch these around actually, because otherwise that doesn't make sense. Like I said, it doesn't matter which one's which. So 8.4 squared, take away 7.2 squared is going to give me a squared. So if I type that into a calculator, 8.4 squared, take a 7.2 squared gives me 18.72. So I know that a squared is 18.72. And how do I get a? I have to do the inverse, which is square rooting. So I type the square root of 18.72, which is 4.3266161531. So I know now that this side is 4.32. Now, what I need to do is work out the area of the front face. So how do I work out the area of a triangle? Like we said before, it's base, which is 4.32. And I can just save that in my calculator. I don't touch my calculator. And then I don't need to write everything out. So I'm going to do base times by height, 7.2, divided by 2. So 4.362 I leave on my calculator. I times it by 7.2. And then I divide by 2. So I know the area is 15.57598151. And that's the area of the front of the prism. Now, what I do once I work out the area, I multiply the area by the length. So I'm just going to do 15.57 times by 18. And if I've left it in my calculator, I don't need to write it all out again. I just multiply by 18. And that gives me an area of 280, or volume, sorry, 0.3676672. And it says, give your answer correct to 3 significant figures. So 1, 2, 3. This is the third significant figure. I look next door. 3 is less than 4, so I know I'm rounding down. So that would be 280, and it's going to be centimeters cubed because it's... Next, I've got a rectangle. It has a width of y and then a length of 2x plus 6, which is the equivalent to 5x minus 9, because in a rectangle, opposite sides are equal. Okay, so I'm told that all measurements are in centimeters, and the area of the rectangle is 48 centimeters squared. Show that y is 3. Okay, so there's a few things that I can do. First of all, what I can do is figure out what the value of x is. And I can do this because I know that this side is equal to this side. So I can set up an equation for myself. I know that 2x plus 6 must be equal to 5x minus 9, as they are both opposite sides of the same rectangle. So it's a little bit of a tricky equation to rearrange because I've got x variables on both sides. And when this happens, just subtract the smaller variable from both sides. So I'm going to take 2x because that will cancel it out here. And I have to do the same to this side to keep the equations balanced. So that would give me 6 equals 3x take 9. And now I've just got a normal solving equation. So I do what I'd normally do, cover up the x. What is left? A negative 9. So I'm going to add 9 to both sides. So 6 plus 9 is 15. So 15 is equal to 3x. And if 3x equals 15, the next part would be to divide both sides by 3, because 3 is being multiplied by x. So that cancels over here. And I'm left with x equals 5. So I know that this side and this side have a length of 5. Now, I'm also told that the area is 48 centimeters squared. So I know that 5 times by y must equal 48. So if 5y equals 48, oh, sorry. This is why you need to read the question very, very carefully. So of course, the side does not equal 5. I've worked out what what x equals. So now I substitute it back into the expressions for the sides. So if x is 5, 2x is going to be 10. 10 plus 6 is 16. Let's double check if that works for this side as well. If x is 5, 5 times 5 is 25. 25 take away 9 is 16. That makes a lot more sense. So that means that 16 times by y is 48. So 16y is 48. So to figure out what y is, I'm going to need to divide by 16. Divide both sides by 16. So y is 48 over 16. So I've got a fraction here. To show this division, I can just simplify the fraction. So let's start by dividing by 2. So 48 divided by 2 is 24. 16 divided by 2 is 8. I can divide by 2 again if I don't quite know what this is. 24 divided by 2 is 12. 8 divided by 2 is 4. If you can't see that 12 over 4 is 3, that's fine. Divide by 2 again. So that would give you 6 over 2. And 6 over 2 equals 3. So if you've shown all of this calculation, you show that y equals 3, because 3 times 16 makes 48.